expert system with applications, 5 international patents, more than 10 book chapters, and 1 book in Turkish. He is editor of more than 10 books. His research interests include wireless sensor network, wireless communication, statistical signal processing, indoor positioning system, Internet of Things, power electronics, and 5G. He is the associate editor of IEEE Potential magazine, handling editor of microprocessor and microsystem, elsewhere associate editor of IET Electronics Letters, IET Networks. He has also guest editorial positions in IEEE Internet of Things magazines. He served several reviewer positions for IEEE Internet of Things Journal, IEEE Sensor Journal, and IEEE Access. He serves several book editors position in IEEE Sensor Journals, and IEEE Access. He served several book editorial positions in IEEE Springer, elsewhere, Wiley, and CRC. He presented 40 plus keynote talks in reputed IEEE and Springer conferences about wireless sensor networks, IoT, and 5G. He is a senior member, IEEE, and professional member of ACM. Dr. Senzik awards and honors include the Tubitak Priority Areas PhD Scholarship, the Khadir Has University PhD Student Scholarship, Best Presentation Award in ICET 2016 Conference, and Best Paper Award in ICET 2018 Conference.
Thank you so much.
So today, sir will enlighten with us his vast educational knowledge. Over to you, sir.
Okay, thank you. Again, good morning, everyone. Now let me share my screen. Is it visible?
Yes, sir. Screen is visible.
Okay, thank you. Okay, I'm Dr. Korhan Cengiz from United Arab Emirates, and now I'm joining from United Arab Emirates. Today's our topic is novel routing protocols for wireless sensor networks. Especially in my PhD studies, we designed 2 novel protocols for wireless sensor networks, and we were working about network layer. And nowadays still, we are studying and working on wireless sensor networks and routing protocols, but actually we are trying to combine these solutions with IoT networks with my colleagues and with my new and ongoing PhD and Master of Science students. So today I will try to explain you briefly, as much as possible, these 2 novel protocols, some open research topics, challenges for new researchers. So our outline, as you see, we will start with motivation and related works about these topics, and especially the fundamental protocols about these topics. And our design 2 protocols. One of them is low energy fixed clustering algorithm. We call it LEFCA. The second one is multi-op LEFCA, and it's an extension of LEFCA. And it is the combination of LEFCA with especially wireless networks and multi-op routing. And it is simulation and results, and finally conclusions and future scope. So as a motivation, we can briefly tell that wireless sensor networks are widely used in several applications. When we check internet and the resources, we can see that wireless sensor networks are used for especially disaster relief, target tracking, environmental control, smart cities, medicine and healthcare, and especially in healthcare systems. Nowadays, we are using wireless sensor networks frequently. And in wireless sensor networking applications, to distribute the sensed data from the environment or from body, from any place. In literature, we have 3 main approaches: direct transmission, multi-op routing, and clustering. in direct transmissions, our sensor nodes are able to collect information from the environment and then transmit these information to the remote base station or base stations. In multi-hop routing, some sensor nodes can be used as relay nodes, and by using these relay nodes, we can transmit again the sensed information to the remote base stations. And in finally clustering, there are some cluster formations, and cluster heads are responsible to collect the sense data from the normal sensor nodes and combine this data and transmit to the remote base stations. Actually, our LEFCA protocol is a clustering protocol, and our multi-hop LEFCA protocol is a combination of clustering and multi-hop routing ideas here. And for us, as we know that, direct transmission is a traditional way, but it is very costly. So therefore, approximately in almost all applications, algorithms, protocols are trying to decrease the communication costs of direct transmission in the literature. And generally, we see that in the literature, protocols are frequently using clustering. Okay, so we will try to discuss especially in these manners. So in networking of wireless sensor networks, when we see that there are some general problems, especially we can see three problems here: increase in energy consumption, decrease in network lifetime, and additional network overhead. And as you see, generally, these problems are related about energy, because wireless sensor networks are restricted about energy, and generally they are working in remote environments. They are used for sensing information in the environment, and they are not easy to access when they build. So therefore, we should make them energy efficient as much as possible. So our proposed LEFCA is trying to solve these issues by using two ideas, mainly fixed clustering and changing the cluster head election process of traditional algorithms. Almost all of them, as we said, using clustering. LEFCA also using clustering, but LEFCA provides some novel solutions and ideas to the existing traditional clustering protocols in the literature. And when we check the related works, when we are studying in wireless sensor networks, also, if we are planning to start to study in this field as a new researcher, okay, we have to check leech protocol, because leech protocol is the most fundamental protocol in wireless sensor networks. And approximately 20 years ago, it was found, and it has two phases: setup phase and the steady state phase. In the setup phase, leech is trying to make cluster head election, cluster head advertisement, and cluster formations. And in the steady state phase, the main main objective is transmitting data to the remote base station. But here, when we check leech protocol truly with details, we see that leech protocol is very successful, and it is working very stable. And it's also energy efficient protocol, of course, but There are some another problems that should be solved. For example, leech protocol is making cluster head elections according to probability-based idea. So for some cases, we noticed that there is no cluster formation in leech protocol. And this can be very big problem, especially for critical applications. For example, consider that you are using your wireless sensor networks for fire measurements. Let us say that you are using wireless sensor network for healthcare applications. So for these kinds of applications, always you need to collect data and you need to transmit this data to the remote base stations. So therefore, for some rounds in leech protocol, there is no cluster. There is no cluster formation. So it means that you cannot collect any information from the network and it cannot provide you full network connectivity. So to be reliable and to provide full network connectivity, you need to generate some additional new solutions. So therefore, especially for critical applications, when we found these problems of leech, we decided to generate two novel protocols. Okay, this is our main reason. And of course, our proposed Lefka and Maltop-Lefka protocols provide us energy efficiency and energy savings. I will, of course, explain them in the simulations and also results session. So, but this is our main objective. And when we check also literature, we can find thousands of extensions to the leech and leech-based protocols. And these protocols generally are trying to change cluster selection mechanism of existing leech, determining cluster heads according to the remaining energy and using fixed clustering. So in proposed algorithms designed by us, we are using these ideas and we are including a new paradigm to these ideas. I will also explain it, but we are using all of them. In some protocols, they are using sometimes one of them, sometimes some of them. But in our proposed idea, we are using all of them. Also, I will explain it. And also, when we check the literature, as we said, you can find thousands, but some of the famous fundamental ones, for example, leech-F protocol. Leech-F protocol is using fixed clusters because in leech environment, original leech environment, the clusters are not fixed. So clusters are changing in each round. And here also it is better to, I think, explain round now for some, researchers, what is round. For us in wireless sensor network, a round corresponds to time, which is transmitting the information to the base station. And if we want to explain further, our sensor nodes are sensing the environment, they are collecting the information, and then they are transmitting this information to the associated cluster heads, and cluster heads are combining and making single packet and then transmitting these single packets to the remote base station. And all these activities correspond to one round. And when you consider in real time, according to analysis calculations of leech, this is a approximately equal to 20 seconds, for example. Okay. So, but this is, of course, these values are in, simulations, and it should be analyzed in different cases, but we are not interested in that part, actually. It's not our topic here. So these all activities correspond to one round. So, as we said, in leech and leech-based protocols, for some rounds, we cannot find any cluster and any cluster formation. So therefore, instead of using different cluster formations, variations, according to probability in each round, we are trying to use fixed clusters. So also LeechF is trying to use fixed clusters. And when we check the results and especially analyzes implementations of LeechF, we see that LeechF is better than Leech protocol, according to especially energy efficiency and network connectivity. But we saw that LeechF still not enough to solve some problems, and especially energy efficiency problems of the network. So when we are talking about LEFCA, LeechF is the fair candidate for comparisons. So therefore, we included LeechF in our comparisons, in our analysis. And also there is mode leech. Mode leech is also one of the most fundamental protocols, and it can be also used, and when you make wireless sensor network protocol, when you design an algorithm, you should include mode leech in your comparisons, because it's also most fundamental, one of the most fundamental protocols. And also DEEC is another most fundamental protocols in this field. And stable election protocol is another one of the most important protocols. So as you see, when you start to study in any topic, as we know, as researchers, you should include some fundamental protocols ideas for comparisons. And of course, from the literature, you should include some novel and current technologies or protocols to show that your protocol, your idea is better than them for some cases, or instead of using them, you have some, additional improvements. You should prove it, as you know. This is the main mechanism of research. So therefore, for this case, we included these kinds of fundamental protocols. And of course, in our comparisons, we included some novel protocols from the literature. And also lemma is another related work, iLeech, pLeech. We can, increase these numbers. It's okay. But now let us try to understand LEFCA with details, how it is working, and what are the main novelties of LEFCA for the literature. Now, our LEFCA, as we said, using fixed clustering and cluster head determination approaches, and these activities, these main actions done by base station. So in our protocol, base station is the boss. Base station decides the important actions. And our LEFCA aims to use fixed clustering and cluster head determination approaches together. There is a combination here. And this is the first novel part of our protocol, for example. LEFCA uses intelligent cluster head determination mechanism, and this intelligent smart mechanism tries to elect the nodes that are almost at the center of their associated clusters at the beginning of the algorithm, instead of determining them randomly. And we, of course, tried random determination, and generally in sensor networks approximately all algorithms using random determination of cluster heads for several rounds or at the beginning. So we decided to use intelligent cluster head determination, and we made some analysis and comparisons with random determination for the beginning of the network. And we found that intelligent determination provides us approximately 10% additional energy savings. So therefore, we decided to use intelligent cluster head determination instead of random determination. And here, for example, I will explain in future scope, but sometimes I will give you some, ideas to the researchers while talking about some parts. For example, here, some machine learning solutions, some artificial intelligence-based ideas can be applied, LEFCA, to make this intelligent cluster head determination better. So, for example, this is an open research topic for us. Nowadays, still here, we can generate some solutions together with new researchers. And also, the second novelty of LEFCA is introducing a threshold-based cluster head change mechanism. And this threshold is mainly based on the energy of the existing cluster head. When we check the literature, you can find these kinds of ideas, okay? This is not pure novel, but it's a novel. But as you see here, our LEFCA is aiming to exploit the energies of the cluster heads before determining a new cluster head. This is the exactly novel part of LEFCA, and this was not tried in any algorithm, any protocol before. So LEFCA generated us too many publications in IEEE, for example, Access Journal, in another SCI journals, more than 5-6 IEEE conferences. And still we are having publications because still we have novelties and improvements in LEFCA network. So this idea was not tried. But this idea is dangerous because you are trying to exploit the energy of the cluster head. And for example, if our cluster head becomes out of energy, it means that for the next round, for example, if that cluster head remains as a cluster head, it means that you will not get any information from the network for that region. So for critical applications, this can be disaster, because our main objective here, as you know, trying to solve the problems of leech and trying to generate full network connectivity. So therefore, we should be careful here, especially determining the threshold of cluster head election. So maybe this idea was not tried because of these, problems, restrictions. And for this case, we made further analysis, mathematical analysis, to find the exploiting of cluster heads by providing, keeping network connectivity. This was an, hard problem to solve, but I solved in my PhD studies. So I will explain that part again. And our LEFCA has two phases, same as in other protocols. setup phase and the steady state phase. In setup phase, we are determining the cluster heads according to our smart idea. And then cluster heads providing TDMA schedules to the cluster members. And these TDMA schedules broadcasted to the network and the members. And in the steady state phase, these members are responsible to transmit data to the cluster heads. And finally, cluster heads are responsible to transmit information to the remote base stations. So these mechanisms approximate the same in all, wireless sensor network protocols. And this is the, for example, setup phase of LEFCA. And we have some wireless messages, propagation messages in the network. And by using these messages, we are providing especially packet transmissions. As you see, mainly we have two messages here. Cluster head advertisement message. Basically, it says that I am the cluster head. And when any sensor member gets this message, it understands that, okay, this is the cluster head. And another main, one of the main messages in the network for us, from the cluster members, join request messages. Normal cluster member, normal sensor node tells that I want to join your cluster. So according to received signal strength of the messages, as you know, the fundamental wireless communication aspects, cluster head determinations and cluster head partitions are done by using these messages. And after that, cluster formation provided. And as you see, our cluster head responsible to provide TDMA schedule. And this TDMA schedule, as expected, has time slots. And time slots for each node in the cluster and time slot for cluster head. So for example, if you have 10 members in the cluster, you need 11 time slots, because also you need to provide one time slot for your cluster head, because end of the collection of the messages packets from the normal sensor nodes, cluster head responsible to combine and make this message into single packet and transmit this message to the remote base station. Okay. And this is the steady state phase of LEFCA. In the steady state phase, as we said, we are making data transmissions. And our main objective is transmit the collected information to the remote base station. And this part, as you remember, we told the novel part of LEFCA and important part. And as you remember, we told that we are exploiting the energies of the cluster heads before selecting new one. So this part for us is cluster head change decision part. And here we are using a threshold value, as we said. And we said that while determining this threshold value, we should be careful to provide full network connectivity. So, for example, here, if the cluster heads remaining energy, residual energy, is higher than the determined threshold value, for the next round, our cluster head continues as a cluster head. If not, it should be changed. And here, in original LEFCA, we are changing cluster heads after the threshold randomly, but also selecting the node with highest energy, selecting the new cluster head, which is nearest to the existing cluster. These kinds of also ideas were used in LEFCA for different IEEE conferences, for example. And one of them was presented in IEEE Black Sea Con, one of the most important conferences of IEEE. And here, actually, and we are, while trying to determine our threshold value, we said we should be careful, and we are trying to exploit it. And if we determine this threshold value very small, our cluster head can be out of energy. And if we, determine this value is very large or large, then our, LEFCA will approximately work as leech network, because, for every round we will change our cluster head, but we don't want this, because we are trying to also decrease the number of messages and network overhead in the network. Because when you change cluster head, what will happen when you change frequency? Your cluster head should send broadcast message, I am cluster head, and all nodes should send join request messages. So it will generate too many network cost, network overhead. In addition to these network costs, you will consume energy, because when you transmit any message in the network, of course, you are, consuming energy. And here, our sensor nodes restricted with energy, especially, for example, on simulations, we consider that our sensor node is, starting with 2 joules initial energy. And approximately one sensor node can stay, for example, 3,000 rounds, 4,000 rounds, approximately, average. So when you increase the number of cluster changes, you are decreasing the lifetime of the network dramatically. So therefore, to provide energy efficiency, we should keep the number of cluster head changes and number of cluster formations minimum as much as possible. So therefore, we decided to use low threshold value. We decided to use exploit the energy of the cluster. But as we said, we should be careful here. So how can we determine the safe threshold value to really, be sure that our cluster will be connected and we will provide full connectivity, network connectivity? How can we calculate it? By using this main formula, we can make this derivation calculation. This equation basically shows that energy of a cluster head can be calculated by using these terms. And here, the most important, term for us, D to BS, distance to base station. And as you see, we are here having the fourth power. This fourth power is coming from crossover distance. And for our cases, for example, the crossover distance is 87 meters. This means that the distance of the cluster head to the base station is higher than 87 meters. It will consume its energy according to the fourth power of this distance. If it is lower than 87 meters, our cluster head will consume its energy according to the second power of this distance. So all also clustering algorithms are, moving from this distance, this crossover idea. So they are trying to decrease the distance of the cluster heads to the base station to decrease the energy consumption. So when you use clustering, of course, your cluster heads generally becomes lower than this distance. So therefore, you are consuming less energy, and in the energy calculations, you are using second power. Okay. So by using this formula and by considering the worst case, we thought that we can determine our threshold value. So what is the worst case for us? The worst case for us is considering there is only one cluster and there is one cluster head, of course, and this cluster head, for example, located in the origin of our network, the farthest, remotest node to the base station. And let's say we have 100 sensor nodes randomly distributed to the environment, and we have 99 normal nodes and one, cluster head, and this cluster head in the coordinates of 0, 0. So for this case, for one round, how much energy this worst cluster head will consume? We wanted to calculate this for the worst case, okay? So according to our calculations, we found that for this case, our cluster head approximately will consume 0.005 joules. And as we said, our sensor nodes, starting with 2 joules initial energy at the beginning. So then we decided to use that for safety. We thought that we can use the threshold value, forced threshold value in Levka, that the 10 times higher than this value, okay, to provide full network connectivity and to provide full exploiting abusement of the cluster head. So therefore, we decided to determine the threshold value for Levka network is 0.05 joules. Okay. So in Levka network, for example, if we have 8 clusters at the beginning, each cluster head should be used until its energy reaches to 0.05 joules. And when it reaches, for the next round, future rounds, we have to select new cluster head randomly from the alive members of the associated cluster. Okay, we should continue like this. This is the main mechanism, main idea in Levka, and this is the novel part of Levka. So now I will explain you multi-op Levka in one slide, because our time is limited, of course, and then I will talk about the results and future scope, and then we can have some questions if you have. So our multi-op Levka, as we said at the beginning, is the combination of clustering and multi-op routing. When you check the literature, you will find too many also approaches for multi-op routing. In multi-op routing, main idea is this: using some sensor nodes as relay nodes, gateway nodes, to decrease the transmission distances. Okay. So normally, when we check this figure, what's happening in Levka, normal Levka? Consider that this is normal Levka, not M Levka now. For example, in normal Levka, for us, by using the intelligent cluster determination, at the beginning, let's say we, determined node 5 not 15, not 20, and not 11 as a cluster head. So what will happen in normal Lefka network? Other sensor nodes will get the information, sense the information, and transmit these information to the cluster heads. And these cluster heads will make a single packet. And for example, node 5 will transmit this packet to the base station individually. Node 11 will do it. Node 15 will do it. And finally, node 20 will do it. Okay. But in multi-op Lefka, especially, for example, for node 5, instead of transmitting to the base station directly, it transmits this information to the nearest next cluster head. So for him, for example, the nearest next cluster head is 11. So here, 11 is responsible to transmit the information of cluster 1 and cluster 2. So it is transmitting this information to the node 20. And here also 15, another cluster head, is responsible to transmit information to node 20. And as you see here, node 20 is responsible to transmit whole information of the network to the base station. So, for example, here we have one more open research question now. Node 20 has very critical role, especially this cluster, because it is the nearest cluster to the base station. If any, thing happened to node 20 or this cluster physically, for example, let's say these guys became out of energy. Let's say they are not working. So what will happen? We will have very big problems and we will, lose all network connectivity, all information. So how can we find a new solution or some solutions for this case? This is also another open research topic for us. Okay. And when we check the results briefly, as you remember at the beginning, I told you that original Lefka using random cluster selections for the new cluster members. But also, we can use intelligent cluster selection, and we decided to use intelligent cluster selection at the beginning. So when we apply intelligent cluster selection and random cluster selection, as you see, intelligent cluster selection provides us approximately 10% additional energy saving. Therefore, we decided to intelligent cluster selection. And for researchers, how can we make this intelligent cluster selection mechanism smarter? And can we apply some, artificial intelligence, machine learning, deep learning based solutions here? This is also another open research topic for us, okay? And this is the impact of the threshold value. And as you know, in Lefka, we are trying to exploit and we are trying to use as much as possible lowest threshold value. And when we increase the threshold value, our, results and our performance, especially decreasing instead of energy efficiency. So therefore, we are, obtaining low lifetime, okay? And we also obtained the energy map of the network for Lefka, and we made comparisons about leach. For example, after 3,500 rounds, when we, get a snapshot from the network, okay? Leach network looks like this, and Lefka network looks like this. And as you see in Lefka network, it is still possible to collect information from all parts of the network, all parts of the environment. But in leach network, there are too many black nodes, and black nodes for us mean, dead nodes, means out of energy. They cannot communicate, they cannot make any activity. So for some parts of some regions of the network, as you see in the list, you cannot get any information. And from this figure, this snapshot, we can understand that Lefka is very suitable for critical applications. And Lefka provides reliable data transfer from the network to the base station. For example, when you consider in terms of throughput, okay, Lefka provides very nice, very reliable throughput results. I will show it also in another graph. And when we check for example, after 1,000 rounds, let's say we made 1,000 more, packet transmissions, Lefka looks like this. And as you see, still it is possible to collect information from approximately all parts of the network. For example, the remotest cluster, there is one node still alive and he is serving as a cluster head. So he is transmitting information to the base station. And for example, this is the residual remaining energy of the nodes in terms of rounds. And as you see, Lefka has robust, nature, and it has the best energy efficiency performance when it is compared with new algorithms and also fundamental algorithms. And in some of them, we are using, hybrid networking architecture. For example, in some of them, especially SEP and DEEC, there are some advanced nodes, and these nodes have more energy, more initial energy. Therefore, for example, total energy value is 250 joules for 100 nodes, but other ones has normal nodes, so it has 200 joules. And also this, for example, advanced nodes idea can be applied to Lefka network, and especially, for example, for the farthest nodes, we can put some, advanced nodes to increase the lifetime of Lefka. Or for, solving the problem of multi-op Lefka, we can include some advanced nodes to, increase the lifetime of Lefka again. So this idea also can be applied for Lefka and multi-op Lefka networks. So this is also another open research topic for us. And this is the number of alive nodes of Lefka and other protocols. And to make it fair, of course, we are all starting with 100 nodes. And we always use the same distribution for our algorithms. And according to results, as you see, Lefka has approximately a linear, behavior, and it is reliable and robust when we check the results, and it provided the best, energy efficiency performance. And these are the network lifetime results also in terms of, rounds. And as you see, Lefka network approximately provides average 5,500 rounds lifetime. When we compare it with, for example, leech and leech-based protocols, this is, as you see, big improvement. And as you remember, we were talking about throughput, but here, instead of, defining as throughput, it's better to, define it total data transmitted to the base station, or total number of packets transmitted to the base station is better, because throughput is a different story, as you know. So here, as you see, especially our Lefka provides to transmit, number of packets each round, and it guarantees this transmission. For example, let's say Lefka starts with 10 fixed clusters. So first round, it will exactly transmit 10 packets, 10 packets, 10 packets. It will continue like this. Let's say the remotest, farthest cluster died, became out of energy, then it will continue 9, 9, 9. So it is easy to, monitor and easy to, collect information from the Lefka network. But in leech-based protocols, as you know, we told at the beginning, this was the main problem also. For some rounds, there is no cluster. There is no cluster head. So you cannot collect any packet from the network. But in Lefka network, it will continue like this: 10, 10, 10, 9, 9, 9, 8, 8, 8. So it's easy. And you will know that which region died and became out of energy. So you can generate some solutions. For example, you can generate some solutions, let's say physically, for this case, okay? And for different node densities also, we made some investigations. What happens when we decrease number of nodes? What happens when we increase number of nodes? And what happens when we put base station instead of out of the area, when we put into the, or middle of the area? As expected, the, lifetime of all algorithms, protocols, increased. And briefly, when we compare with multi-op Lefka with Lefka, multi-op Lefka provided us approximately 10% additional energy when it's compared with Lefka, okay? And, okay, as a conclusion and future scope, today, in this keynote speech, we talked about two novel routing protocols for wireless sensor networks, Lefka and multi-op Lefka. Lefka is a fixed clustering protocol, and it uses threshold-based cluster as selection mechanism, and it is trying to exploit the cluster heads, energies of the cluster heads, before electing new cluster heads by using this threshold mechanism to increase the energy efficiency of the network and to provide full network connectivity, to assure full network connectivity. Multi-op Lefka is an extension, improvement to Lefka. It is an enhanced version of Lefka, and it is trying to combine fixed clustering with multi-op routing, and it's mainly using the neighbor cluster heads, cluster head nodes as a relay node, gateway node, and it is trying to decrease the transmission distances of the cluster heads, and it is trying to increase the especially lifetime of the network. And basically and briefly, multi-op Lefka provides 10% additional energy savings when it's compared with Lefka. And as a future scope, as we told, for example, Lefka uses intelligent cluster heads, so some machine learning, deep learning solutions can be applied at the beginning of Lefka network. For the multi-op Lefka, the nearest nodes and clusters to the base station has strong network load, and they have very critical role. So for this case, what kind of solutions can be generated if any problem happens. This is also another future scope for us. For example, for large-scale networks, we didn't try Lefka. So how can Lefka behave in large-scale networks? This is also another open research problem for us. And also, for example, Lefka, as you see, is working for fixed clustering. How can we make Lefka mobile? This is also another open research problem, and this problem, okay, for example, can be hard, but it is very suitable for example, PhD study or postdoc research. So these are some sort of open research problems for us. Of course, we can generate new problems and discuss with new researchers about new problems. For example, including some software defined networking solutions to Lefka network. Generating some, new ideas and solutions with Internet of Things. How can we apply Internet of Things based solutions to Lefka? These are our new open problems. So thanks for listening and thanks for your kind invitation. If any question, we can discuss now.
Yes. Now I would like to take questions from participants. So one question is there. Is the base station and sync nodes are same? Means they are among the sensor network nodes?
Yes, for us same. In some resources, they are mentioning about sync node. In some resources, they are mentioning about base station. Both of them same for us.
Okay. So, another question is regarding gateway. Gateway concepts in wireless sensor network, means how gateways are work.
Okay. Actually, in some, studies, some ideas, they are also generating some gateway nodes, and these gateway nodes sometimes, can behave like base stations, and they have some, additional facilities. Okay. So we consider them, mini base stations. But in our multi-op Lefka, our gateway nodes are selected from our cluster heads, and they are normal sensor. Just we are using our selected cluster heads as gateway nodes. So for some resources, you can name it gateway nodes. For some resources, you can name it relay nodes also. They can see like that also in some studies. Both are same for us. But sometimes gateway nodes, yes, can be different and can be, set up with additional facilities and features. It can be possible, yeah.
Yes. Any other questions from participants? Yes. Data-centric protocol. Is it means data-centric protocol? So what do you mean by data-centric protocol?
Data-centric protocol, especially now in wireless sensor networks, generally, let us clarify this point. This is important. In wireless sensor networks, generally, we are working in network layer. Okay. Third layer of the oscillators, as you know. So therefore, we are directly and only interested in packet transmissions. So we are not interested in data or content of the message. For us, you can consider that like, delivery. When, cargo, company gets your packet, delivery packet, for example, delivery agent, not interested in the, content. He just brings you your packet and this is your delivery service. So here also our nodes, cluster head nodes especially, making the same. Packets are coming to them, information coming to them. They are making single box and then transmitting this box to the remote base station. Their main duty is like this. But in data-centric protocols, they are also interested in data, content, and they are making some compressions and another algorithms, applying some another solutions to the data to decrease the energy consumptions. And these protocols mainly working in second layer, data link layer of the oscillators, and especially they are using some medium access control layer algorithms, MAC layer algorithms. And also sometimes we can see some hybrid protocols which are using data link layer and also network layer. They can see also these kinds of protocols in the literature, but our Lefka and Maltop Lefka directly working in the third layer, network layer. Okay.
Yes, sir.
Sir, hello. Hello.
Yes.
Hello.
Yes.
Hello, sir. Myself, Pratik Hazare. I want to ask one question. Is there any relationship between node density and energy? Node density and energy of the nodes.
Okay. This is also a good question. For this case, let us go back. For example, our Lefka network working with 100 nodes.
Oh.
When we decrease the nodes, number of nodes, and when we increase the number of nodes, what's happening? As you see, when we increase the number of nodes, as expected, the energy performance of the network is increasing. Normally, from outside, you can think like, if we increase the number of nodes, they should, use more energy. No, because here, when we increase the node density, our transmission distances is decreasing because there are more nodes and more candidates to be cluster head, and the transmission distances between the members decreasing. So therefore, it provides energy savings. But this is interesting result. But when we make it, for example, 500 nodes, 1,000 nodes, 1,000 nodes, what will happen? This is also open research problem for us because there should be optimum value for the region. Okay, this should be also calculated and derived. For example, this can be a very nice PhD thesis. Yani, what is the optimum number of nodes for this, for example, area? Because generally, when you open any, wireless network protocol paper, 100 nodes randomly deployed to 100 meter to 100 meter and enjoy. But what is the main idea? Mathematics behind this. This is also another open research question for us. So you asked a very nice question. Thanks for it. Thanks for your contribution also. So actually, for this case, it increased. But what is the optimum number for node density? This is open research question. Still open, yeah. Okay.
Can we work on mitigating flooding effect when the node density is high?
Yes, it can. This idea, for example, can be applied. Yes, it can be a good trial and maybe good solution. This is a good idea. It can be applied for node density.
Since we don't have any type of, say, learning sequence, can we apply reinforcement learning in this case?
Yes, reinforcement learning can be a very nice solution for this. And reinforcement learning, as you know, very novel topic for us. And reinforcement learning nowadays is applying too many fields, also mobile communications, wireless communications. So yes, this can be a good idea. For example, we can collaborate about this topic together, yani, with you, with your colleagues. It is open question for us. Nice idea.
Thank you, sir.
Always welcome.
Yes. Any other question from participant?
I can type also my IEEE email to the friends. As I told, especially, we are ready for collaborations with our colleagues and with our friends, with our new students. Also, we are ready for being, co-PhD supervisor for your PhD students. Always welcome. You are free to communicate and connect with me. And we can have, inshallah, future fruitful collaborations together. Thanks for the kind invitation again. It was nice to be with you here.
Yes. Thank you, sir.
Thank you, sir.
Always welcome.
Thank you, sir, for your valuable inputs. I request you to please accept the token of gratitude on behalf of organizing team and Yashwantrao Chauhan College of Engineering, Nagpur, for sparing your valuable time and guiding us in such a wide network area. So thank you, sir. Thank you once again.
You are always welcome. Thanks.
Thank you. यहाँ पे आ जाना बोल बेटा 2 मिनट के लिए आ जाओ सेशन चालू कर दो So I request participants of track 6, please stay here. Participants of track 6. Others can leave section. Okay, no?
Welcome everyone. Thank you for joining us for IEEE ICETMS 2022. My name is Dr. Megha Chakole, working as an assistant professor in the Department of Electronics and Telecommunication Engineering, YCC Nagpur. Our track is track 6 and the track name is Signal and Image Processing. Our session chairs are Dr. G.M. Asutkar sir and Dr. A.S. Khobragade. So, if you have any questions during the presentation, please type them into the question box in your control panel. I will read the questions after the presentation, and we will also have time for question towards the end of this session. I also request the presenters to turn on their camera on. Kindly mute your mic when you are not speaking. Now, the first presenter is paper ID 148. Now I'm sharing the PPTs of, now I'm playing the video for the paper ID 148.
Good morning to one and all present here. I am Amrin R. from Panimala Engineering College, Chennai, pursuing a BTech degree in Artificial Intelligence and Data Science. Today, I am presenting textbook to Braille book conversion using pattern matching technique. The co-authors are Subhashri Sudhakar, Priya R., V.D. Ambed Kumar, Tarun C., and Chitra B. I thank my guide, Dr. V.D. Ambed Kumar, for guiding us through the journey. Objective. Not everyone has equal abilities, but everyone should have equal opportunity for education. To make sure everyone gets equal opportunity to gain knowledge, irrespective of any kind of discrimination, such as physical disability, etc. Physical disability must not stand in the way of acquiring knowledge. Even without sight, there is still vision. Abstract. Braille is widely used tactile system that uses different combinations of raised dots to represent the alphabets, words, punctuations, and numericals, allowing blind and visually impaired persons to read and write by touch. It is estimated that around 49 billion people among the world population is blind. The majority of the Braille conversion methods which are opted currently are quite expensive. To bridge the paucity of knowledge between the blind and educated class, it is important to provide them with the accessibility of knowledge between the blind and educated class. I am Amrin R from Panimala Engineering College, Chennai, pursuing a BTech degree in Artificial Intelligence and Data Science. Today, I am presenting textbook to Braille book conversion using pattern matching technique. The co-authors are Subhashri Sudhakar, Priya R, V.D. Ambed Kumar, Tarun C, and Chitra B. I thank my guide, Dr. V.D. Ambed Kumar, for guiding us through the journey. Objective. Not everyone has equal abilities, but everyone should have equal opportunity for education. To make sure everyone gets equal opportunity to gain knowledge, irrespective of any kind of discrimination, such as physical disability, etc. Physical disability must not stand in the way of acquiring knowledge. Even without sight, there is still vision. Abstract. Braille is widely used tactile system that uses different combinations of raised dots to represent the alphabets, words, punctuations, and numericals, allowing blind and visually impaired persons to read and write by touch. It is estimated that around 49 billion people among the world population is blind. The majority of the Braille conversion methods which are opted currently are quite expensive. To bridge the paucity of knowledge between the blind and educated class, it is important to provide them with the accessibility of wide domain of books as it is available to the common age. Hereby, we come up with solution to convert textbooks into Braille script by employing machine learning techniques. Our methodology is proven to be cost effective in comparison with existing methods. Literature Survey, Riya Sawant and others, Text to Braille Conversion System 2021. Their paper is based on extracting letters from keyboard and converting into its respective Braille text using a servo motor. It gives instruction through keyboard mode, which is converted into Braille and understood by the visually impaired. N. Anandi and R. Avuday Ammal, Segmentation and Recognition of Text from Image Using Pattern Matching 2017. They have used MATLAB for capturing of the image and using it for segmentation and recognition. C.C. San and others, an analysis of various image pre-processing techniques in Butterfly Image 2021. They have proposed techniques to do image filtering using Gaussian filter on an input image. Sana Shokat and others, Analysis and Evaluation of Braille to Text Conversion Methods 2020. In touchscreen method, they use haptic audio and tactile feedback method for the assistance for the visually impaired. Miftah Hassan and Yaregal Asagi, Recognition of Ethiopic Braille Characters 2012. They have focused on designing an automatic Braille recognition system for identifying Braille script in Ethiopic characters. Hyung Il Koo and Namik Cho, text line extraction in handwritten Chinese documents based on an energy minimization framework 2012. They have proposed a cost-efficient way to recognize and extract handwritten text. N. Falcon and others, image processing technique for Braille writing recognition. 2005. They use input elements are based on the threshold selection, which contains high amount of accuracy for the betterment of the recognition and conversion. Li Nian Feng and Wang Li Rong, a kind of Braille paper automatic marking system, 2011. They have proposed a method to recognize Braille characters from picture and are eventually converted into Chinese for teachers teaching visually impaired so that they can communicate with ease. Proposed method. The numbers of blind people are estimated around 500,000 in the world. As the number of smartphone users increases with technological advancements, the number of blind people are also increasing collaterally. The existing methods to convert the text manually into Braille scripts are not cost effective. Hence, to settle this crisis, we have proposed the following method. In this method, the image is acquired using high-quality capturing gadget and scanned. Later, the image undergoes image pre-processing techniques such as gamma correction, skew correction, and binarization to enhance the quality of the caricatured image. The image is later segmented using segmentation procedure, and the individual characters are extracted using zoning technique. On the other hand, a database is created which consists of equivalent tactile codes for the respective characters. Subsequently, these extracted characters are mapped with the database using pattern matching technique. The output is attained and fed into the tactile printer, which prints the palpable scripts in Braille text. Now, we will look deep into the above mentioned methods. Image acquisition. The first step is to acquire the image from the source using a hardware such as scanner or camera. Images are scanned using the sensor strips present in the scanner. Image pre-processing. This process is done to enhance the clarity of the image scanned from the text to Braille conversion. Gamma correction. Gamma correction performs a non-linear method to input image pixels. An image that adjusts the saturation value, it corrects the luminance of the image and the value ranges from 0 to 1. Skewness correction. The skewness should be removed once the skewed angle is detected. It is done by rotation of the image clockwise or anti-clockwise according to the image scanned. Binarization. It converts the scanned image into a two-toned image which includes black and white. Image denoising. Image noising is caused by sensor due to the fluctuation in the pixels. The removal of the noise from scanned image is denoising. In text images, Gaussian noise is most likely to occur, so we correct it using the linear filter. Feature extraction. Feature extraction is done on image to extract the image necessary components of the image. They are done in two ways, segmentation and zoning. In segmentation, it is a process of extracting and analyzing an image. In segmentation, the pixels of an image is broken down into segments and grouped. A digital image is segmented into different groups called segments that simplify further processing of the image through the reduction of its complexity. Zoning. Zoning is the process of breaking down of character into equal size of windows so that the character inside each window is determined. The values of objects' pixels in each zone are determined when the frame containing the character is separated into many contiguous or non-contiguous zones. Pattern matching. After the pre-processing techniques, we obtain a clear image with segmented text. The next step is to recognize the individual characters and matching it with its suitable template. A database is created which contains alphabets, numerals, and other symbols which is required for basic mathematics. This data set contains Braille letters which is associated with its corresponding characters. Pattern matching deals with predetermined dataset from database, matching it with extracted character from textbook. It involves a sequence of token, checking it whether it is identical to the existing data. Its main advantage is unlike pattern matching recognition, it only matches with the extract pattern. Results. A performance analysis is performed to analyze the performance of a project. It is significant to analyze any project we do for that purpose. We use confusion matrix. Confusion matrix is one of the best way to evaluate our performance. It helps us to analyze in terms of accuracy, precision, specificity, sensitivity using the formula of the confusion matrix. Case 1. For evaluating our model, we use this confusion matrix and the working of the model is studied by plotting charts. Case 1, study versus accuracy. We have evaluated our model on the grounds of various subjects and its accuracy level. A result has come out very well with theory subjects and suffers with subjects containing mathematical equation and scientific notation, such as with science and mathematics. The results are showcased below and the graph is represented. Case 2, it is document versus accuracy. The accuracy is estimated based on the document size. It is found that the conversion is more accurate when the document size is limited. Documents with minimum megabytes as maximum accuracy and vice versa. Conclusion. This paper is designed in such a way that a printed textbook is scanned and converted into its equivalent braille. It will provide instant access of knowledge to visually impaired that is available to the sighted commoner into braille's manuscripts. This model is seen to work efficiently with theoretical subjects with minimal document size and pages. Similarly, this paper is limited to theory only. Future works would also include to convert equations also with full accuracy and precision. These are the references we used for completing this paper.
Okay. Amrin, are you there? Yes, Amrin. Paper ID 148. Author is present. Hello. Hello. Yes, Amrin Rafiq. Amrin. Paper ID 148. Amrin is there.
Madam, he texts, I'm present, but he's not audible.
Sir, am I audible?
Yes, you are audible, but his author, Mohammad Amreen.
Author is Amrin Rafiq.
Yeah.
Please unmute. Amrin Rafiq, please unmute. Yes, Amrin. Okay. She is having some mic problem. Sir, should I take another ID? She is having some problem. She posts the message in the chat box.
Okay.
Okay, sir. So next one is 169. Pritha Mukherjee is there?
Yes, ma'am.
Okay. Now I'm playing the video for Pritha.
Yeah.
169 idea.
Yes.
नहीं वो फिर से वो
Greetings to all. I am Pritha Mukherjee.
Thank you.
1 minute, sir.
Greetings to all. I am Preeta Mukherjee, and today I'll be presenting our group's paper on refractive index sensor based on a metamaterial absorber in the terahertz range for biomedical applications. Our paper ID is 169. And the outline of the presentation is as follows. First, I'll introduce by discussing the concepts of metamaterials and the working principle behind it, why we use terahertz frequency range as the operating frequency range, and I'll also discuss the various applications of refractive index sensing. I'll then discuss our design, simulation, and the corresponding results, and how changes in the parameter used in the design has helped to optimize the design performance, and what metrics we have followed and evaluated to understand this performance. Finally, I'll conclude by discussing the future scopes and possible applications of the sensor. So the first question that obviously arises is, what are metamaterials, given the new applications of various applications proceeded in the current, in the recent decades in this field of plasmonics. So metamaterials are basically artificial structures arranged in periodic manner, where each of these periodic structures of sub-wavelength units. But what makes this metamaterial so unique in their varied applications is that they have tunable optical properties, and this tunability can be carried out by electromagnetic field enhancement, for example, or by varying the permittivity and the permeability, which further depends on the materials that we use in the metamaterial structure, which I'll discuss later. Now, in our paper, we focus on the sensing part, where we take the primary metric, the absorption rate, which is basically the absorbed instant wave. To understand the absorption mechanism, basically in a metamaterial structure, it is formed as in layers of metals and dielectrics. So in each of these metal dielectric interfaces, there exists what you call localized surface plasmas. They're basically charged oscillations. So when the instant wave hits the structure, it couples with these LSPs. And this creates a resonance. And this resonance is what finally creates the absorption mechanism. Now in the terahertz range, or in other high frequencies, the radiation is non-ionizing. So whatever sensing applications we perform in this range, there is no external disturbances that can hinder our application or our performance. And that is exactly why we chose the terahertz range. Coming back to the choice of materials, one very important characteristic is to consider metals and the dielectric, which have low loss. And apart from low loss, metals should be reflective, and two most commonly used metals are gold and silver. For our design, we used gold. And in the case of dielectrics, it should be thermally stable, mechanically flexible. For our design, we used polyimide. Other dielectrics could be used, commonly are gallium arsenide. In the sensing region, in the sensing applications, metamaterial absorbers can be used in refractive index sensing, gas sensing, temperature sensing, and all of these has biomedical applications. We will further discuss the applications in detail in the conclusion part. But in the environmental application, the typical frequency, the typical range of refractive index is taken to be 1.3 to 1.4. For our design, we have taken 1.35 to 1.4. So coming back to the design, we have created 4 pairs of concentric circular ring resonators, CRR, basically which such that it forms a concentric layers of inverted brackets. Right, and these resonators and the metal ground plane are made of gold, where the thickness is T1 of 0.2 micrometer, and the height of the substrate is T2 is equal to 3 micrometer. And the dimension of the unit cell is 100 into 100 micrometer square. So to understand the absorption rate, it is mathematically followed by as 1 minus T minus R. And since we have a continuous metal ground plane, it prevents any form of transmission through the structure. So we can consider that T is equal to 0. So by minimizing R, which is dependent on the S11 parameter, so by minimizing the S11 parameter, we can have maximum absorption. So after you use the CST Microwave Studio, periodic boundary conditions is applied along X and Y axis, and the incident wave excitation is provided along Z axis. Now we can see from this the figures here that the absorption is a near perfect absorption of 97.12% at 2.96 terahertz, and it has a narrow full width half maximum of 0.005 terahertz. Our sensor is polarization insensitive. We have calculated it by varying the angle of polarization phi from 0 degree to 90 degrees. And we have arrived at at our design of using 4 pairs of CRRs through a series of through 4 steps, where first there is 1 pair of CRR, then 2, then 3, and through these processes we have seen an increase in the absorption and a decrease in the FWH, and thus increasing the Q factor, the quality factor. To understand this absorption mechanism, we can look at the surface current distribution, from which we can observe that it is dependent on the radius, because the surface current density is much more, the hotspots are found along the edges of the resonator and at the top and bottom of the unit cell, top and bottom edges of the unit cell. So it is dependent on the unit cell dimension and the radius, or the inner radius, innermost radius, and the outermost radius. So we have considered a parametric justification of the unit cell dimension, the substrate height, and the outermost and innermost radius. And we observe from these 4 parametric justification that given in these figures that the choices that we have for the parametric, for our originally chosen values of the parameters justifies our design, justifies our choices, because these values are the only one that gives the proper, narrower FWHM and the maximum absorption peak. To further understand the sensitivity to the performance of the sensor, we have seen the changes in the absorption rate and the changes in the resonant frequency with changes in the refractive index. So this relation between the refractive index and the resonant frequency can be provided by what is called the sensitivity, which is the ratio of the change in frequency by the change in refractive index unit. And we arrive at a moderately high sensitivity of 1.557 terahertz per refractive index unit. The quality factor, as we already calculated, is inversely proportional to the FWHM. So a narrower FWHM leads to a high quality factor, in this case 593.04. The figure of merit is dependent on the S and the FWHM, a very high 311.4 for a refractive index unit. And this relation between the resonant frequency and refractive index unit is a linear negative slope graph, which is given by this equation: F is equal to minus 1.557, which is sensitivity into N, plus 4.4. So finally, we can conclude that our sensor is lightweight because of the materials that we have used, and it leads to high performance because it has a very high Q, a moderately high sensitivity, and a high FW8, a high figure of merit. In case of biomedical applications, it can be used in early detection of cancer, early diagnosis of cancer, in blood plasma detection, in detection of urine during pregnancy. And it can also be implemented using wireless networks in case of remote sensing, so that it can be further used in the medical industry. And so is our presentation. Thank you so much for attending.
Okay, thank you, Preetha. Now, please turn on your camera. It's a time for question answers. Asutkar sir, please. Hello, Preetha. Asutkar sir. Hello. Hello. Okay, Khobragade sir. Khobragade sir.
Yes, ma'am. Yes, ma'am.
Please ask the question. I think Asutkar sir left the meeting.
Okay, okay, no problem. I just wanted to ask one question regarding is there any particular application the means participant has identified for this research work?
Sir, it can be used in, it has been used in various, for example, as I mentioned in the conclusion part, it has applications in early diagnosis of cancer, in various detection, sensing and detecting, basically.
Okay, you have given some parameters as well as some values. So they were for general applications. You mean to say?
So basically, here we have taken the refractive index unit in relation with the application in the biomedical industry. So as I mentioned that in the biomedical applications, we use the refractive index of 1.35 to 1.4. And so here we focused on the generalized application in the biomedical applications, in biomedical field, so that it can be used in such related applications, basically.
But ultimately, what you conclude from this refractive index values, what is the nature of output you want to say?
The sensor is highly sensitive to its the refractive index in the surrounding cells.
So
Like,
1.35 and 1.4, what this indicates basically? If I have 1.35 and if I have 1.4, what this indicates?
Basically, if we put the sensor in a system of cells, and for example, let me take the example of cancer. So cancer cells. So in cancer cells, if any particular cell is cancerous, the refractive index changes. So if we
whether changes means what? Increases or decreases?
Increases.
Okay.
Increases. So basically, the sensor detects this change in the refractive index, and that is how it detects that it is whether it is cancerous or not.
Okay, so method is what method you are using for that? Meta absorbers. What is the nature of input that sensor takes, and what is the nature of output of the sensor?
Yes, we take the frequency range, the frequency that we the operating frequency range that we in that frequency range we measure the change in the refractive index.
So what is the range of input frequency that is applied?
We have used terahertz.
terahertz.
Yes.
Okay.
It has the because there is no external disruption, so so we can perform
From
it.
where you have generated this frequency? From which instrument?
Since terahertz doesn't like there has been no current infrastructure in India in terahertz, so we have basically simulated it using CST Studio.
Okay, okay. So simulation results you have.
Yes,
okay.
sir.
Okay, no problem. Okay, that's all from my side.
Yes, Asutka sir.
Yes, no question at moment. Okay.
Okay.
Good morning, Asutkar sir.
Good morning, sir. Good morning.
Good morning. Good morning.
Actually, some technical glitch at my end, some network issue. That's
Okay.
what I was not connected to. Anyway.
Okay, sir. Okay. So next ID is 204, paper ID 204. Yes, are you ready? Mohammed?
Yes, ma'am. Yes, ma'am. I'm ready. Am I audible?
Yes, you are audible.
Yes.
Okay.
Now I'm playing the video for you.
Yes, ma'am. Yes, ma'am. Good afternoon, everyone. My name is Mohammad Anwarul Siddiqui, and today I am here to present my paper titled Effective Segmentation of Liver CT Images Using Marker Controlled Watershed Algorithm. Along with me, the co-authors of this paper are Dr. Shailendra Kumar Singh and Dr. Moin Hassan. So let me begin with the introduction of my paper. Liver cancer detection using machine learning algorithm or deep learning algorithm requires that CT scan images to be given as input to these algorithms. But when CT scan of liver is done, then along with liver, other body organs are also captured. So because of this problem, it is necessary that before giving such CT scan images as input to cancer detection algorithms, the other organs must be separated from the liver. Okay, because liver is situated in stomach along with other organs, and if we will not separate liver with other organs, then deep learning or machine learning algorithms might confuse other organs with the cancer cell. Therefore, it is necessary to separate other organs from liver before giving these input images to deep learning and machine learning algorithms. Now, what are the challenges in liver segmentation? The placement of liver in human body. Okay, the placement of liver in human body is not fixed. For different persons, the liver is placed at different location. The shape, size, and volume of liver also differ from person to person. Even for female and male, the shape, size, and volume and placement of liver is different for different persons. Okay, then medical images are also prone to noise. Noise gets captured along with the image at the time of capturing the image. Then there is a problem of over and under segmentation. Over segmentation means while segmenting the liver, we are capturing some portion along with liver which is not part of the liver, and under segmentation means that we are cutting some portion of the liver while doing the segmentation. Okay, then why should we do segmentation? It is the first step in liver cancer detection. It is very important step because it helps us in identifying the cancer into primary and secondary. It also increases the accuracy and speed of cancer detection algorithms. Okay, broadly, segmentation techniques are classified into four major categories, that is intensity based, structure based, texture based, and deep learning based. Now these broad categories are further subdivided into region growing, threshold based, clustering based, statistical based, and machine learning based. The technique that I am proposing here is based on region growing technique. we have tried to identify some of the drawbacks in existing techniques, and we will try to remove these drawbacks in our proposed method or algorithm. The drawbacks that we have identified in our technique is that most of the techniques are time consuming and they require a lot of manual inputs. Also, the machine learning and deep learning algorithms, they require a lot of input training data, and in case of less training data or proper training data, the classification accuracy of these algorithms suffers. So this is the flow diagram of my proposed method. My proposed method is divided into two parts. In first part, the lever image is pre-processed to remove the noise from the lever image, CT scan image, and in the second step, the pre-processed image is used for doing the proper segmentation. The segmentation technique that I am proposing here is based on customized watershed transfer algorithm. We have taken a watershed algorithm and we have added few more steps in the watershed algorithm in order to improve the accuracy of watershed algorithm. The steps that are involved in customized watershed transformation algorithm are first of all, the input lever CT scan image is converted from RGB to grayscale image because color does not have any significance in the cancer detection. Then we are applying Gaussian filtering on the grayscale image. Gaussian filtering is used to remove the salt and pepper noise. Then we apply Otsu's thresholding. Otsu's thresholding is used to is used for is used for smoothing the intensity of the image, because if the image is very dark or the image is very bright, then to smooth out the intensity we are using Otsu's thresholding. Morphological opening is used to separate different objects in the image, and it is also used for foreground estimation. Finally, we apply the watershed transfer algorithm. The watershed transfer algorithm creates the ridge lines, which is later used to separate the different objects from the image. Okay, and each portion is given a label, and finally using this technique we are able to obtain the segmented portion of lever. Now these are the different images that are obtained at various steps. The first image is the lever input lever CT scan image. Then we have the filtered image, that is when we applied the Gaussian filtering on the image. The next is the threshold image, which is obtained after applying Otsu's thresholding. The next is distance transform, that is obtained after applying morphological opening method. Then we have applied the watershed algorithm. Watershed algorithm provides different color to different object, and the same colored region is separated out as a single object. Now we have the knowledge that in the abdominal CT scan image, the largest portion of the image will be liver, because liver is the largest organ in the human abdominal. That is why by using watershed algorithm, whichever portion is the largest object, that will be identified as the liver. And finally we are getting the segmented liver, which is shown in the last image. Now these are the performance evaluation criteria that we have used. We have used a DICE score, volume overlapping error, relative volume difference, and Jaccard index as performance evaluation metrics. These are this table indicates the performance of proposed method, and I have tried to compare it with some of the state-of-the-art methods that were described previously. And as we can see from this particular table, that I have been able to achieve significantly better result in terms of in all the four criterias. Now this I have tried to graphically represent the obtained results. On the x-axis I have mentioned the image number, and on the y-axis I have mentioned the DICE score which I have obtained for each image. So there are total 200 images on which I have performed this experiment, and this is for DICE score, this is for Jaccard index, this is for volume overlapping error, and this is for relative volume difference. Okay, then what are the advantages of my proposed method? The advantages of my proposed method is that it requires very less parameter tuning, it requires very less manual input, it is also very simple to implement, and it gets trained in very less time. The conclusion: my proposed method is based on Gaussian filter and marker control watershed algorithm. Gaussian filter is used to smooth the edges. Marker control watershed transform helps in avoiding under segmentation and over segmentation. And finally, our proposed method is able to achieve better results in terms of dice score, volume overlapping error, relative volume difference, and Jaccard index as compared to other state-of-the-art methods. These are the references. Thank you very much.
Okay, now it's time for question answers. Hello.
हाँ, Mohammed,
Yes, sir.
mm, uh, you have mentioned four methods, or what that VOE stands for?
So volume overlapping error. These are basically evaluation
Different
parameters.
parameters, okay,
Yes, 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 yes.
on which you have means checked your algorithm
Yeah,
on
the
these four
performance of
parameters.
segmentation algorithm is measured by using those four parameters.
Okay, okay. So, what is your actual means result finally? All these four parameters are improved. Uh,
Uh, yes, sir. All these four parameters were improved. Only in one parameter, that is relative volume difference, I was not
yeah.
able to achieve means better results at compared to other state of the arts. But remaining three parameters, I achieved significantly better result from other state of the art methods.
Can you suggest what this four method indicates? Say, suppose if I want to say
Mhm.
VO is large. So, what does at the back end? What that indicates related with cancer?
Uh, Sir, in this particular presentation, actually, we are not discussing about cancer detection. Okay, the first step in cancer detection is basically segmentation. Okay, what do we mean by segmentation is that we want to find out the region of interest, means basically the part of the body where we want to examine that cancer cell is present or not. Because normally it is believed that a single organ will have a uniform properties in terms of either volume or in terms of means some if you are testing in passing some light, so a single organ will will behave simultaneously unless and until you do not have any you can say cancer cell or any other damaged cells. So in this particular thing we are only trying to segment liver from the input CT scan image, because in the input CT scan image other organs are also captured. So we just want to separate out the liver from the other body organs. Now how do we perform this particular thing is, see, we are not, as a computer engineer, we are not expert, we do not know that what is the shape size of a particular lever. So in order to train our system, what we need to do is we need to have a result means segmented image. And what we do is when we segment our image, we try to compare both the images, means one image which is segmented with the help of a medical practitioner, and he has manually segmented the liver image from the CT scan image. So that image is used as ground truth. And one image is that we have
So,
segmented by using another algorithm.
okay, okay, I understand now. So, up to what accuracy you came across now?
Uh,
Manually, doctor, and what your results said.
Sir, that's what I was trying to explain. When I tried to compare my segmented image along with the image that was obtained by the doctor, so all different parameters usually have different values that is considered as good or bad. So means like in relative volume difference, the value that is as close to zero is considered good, because you try to compare the pixels, means what is the pixels that you have obtained in the image and what is the pixel that was given in the original image, and if you subtract these two pixels, the value should come to as close as 0. If it is close to 0, then it is good segmentation. If it is not close to 0, then it is bad segmentation. So for relative volume difference, my achieved result was 0.3, and for all the other remaining methods, the values close to 1 is considered as good segmentation, and all my values were close to 0.9697.
Okay. Okay. Okay, that's all from my side.
Yeah, thank you, sir.
Okay, sir. I think there is problem on the Asutkar sides. So next paper ID. Thank you, sir. Next paper ID is 175. Yes. Presenter is present.
Yes, ma'am.
Okay.
A very good morning to one and all. My name is Shweta Dhonse and I will be presenting paper on quality assessment method for image inpainting. Inpainting is a process of reconstructing damaged or missing part of an image. Initially, this work of restoration was performed by skilled artists and was limited to the paintings and other artworks of eminence. But this process was very tedious and strenuous, and therefore the digital image inpainting was introduced. The image inpainting can be thought of as an interpolation problem in which information from known portion of the image is interpolated to the unknown part of the image. So this figure 1a shows the image I, where the region in white color shows the unknown part of the image, whereas the green color shows the known part of the image, and the problem statement is to reconstruct this white part of the image by using the information present in the green part, that is the known part, and say whether it is visibly plausible or not. So depending on this quality assessment, different methods have been categorized for image inpainting quality assessment, that is called as IIQA. So basically, image quality assessment is referred as the problem of evaluating the perceptual image quality levels, and the goal of this quality assessment is that to evaluate the inpainted image and restore the image in a very visually plausible manner. Though this analysis of image inpainting results each time give different answers, that means they are very result specific, they cannot be generalized, but still there have been two aspects found. One is that the image inpainting quality assessment can be judged by assessing the quality of the textures or restoring the textures in the neighboring regions properly, and also the second is this is called as the coherence of the inpainted regions. And the second, our human gaze is more attracted by the structures or continuous lines than other parts. Hence, a greater weightage is given to associated to the salient features. Many interesting methods for predicting the image quality have been proposed in the literature. So after analyzing this method, as you can see here, these are two results, and we can judge the quality of the inpainting just by mere observing these results. This type of quality assessment is called as the subjective ones. So here is the original image of the rowboat, two people rowing. In the second image, this black portion shows that a mask has been created to remove these people, and the third result is the inpainted image. But as we can see here, the coherence or the it does not go well with the visual coherence of the rest of the image, since you can still spot that there used to be something here. It is not smooth enough. But as in case of the second image, if this object is removed, see the third image where the continuity of this line is maintained as well as the texture is maintained. So you can see this is excellent in painting, whereas this could be categorized as poor in painting. So this is the subjective method. So similarly, there is objective method wherein we need to have either a full reference image or a reduced references or no reference. So in full reference, some part of a full reference, the original image is available. For example, you have a photograph which is damaged and then you are reconstructing. So you are purposefully damaging it and then you are reconstructing the digital image by using the inpainting algorithm, but still you had the ground truth with you. So you can compare the inpainted result with the ground truth. So that comes under the category of full reference IIQA measures. In reduced reference, some information about the original image is with the user. For example, luminance, edges. So some structural properties is known, and from that the visual coherence is calculated. In the third one, that is no reference, no information is available with the user. So these methods, rather, they are more associated where the object is removed from the image and the remaining portion or the void created by the object removal is to be filled by the known portions. So basically, major portion of the image in painting, it consists of blind convolution and hence fall under the category, and hence the assessment of these images fall under the category of no reference IIQA measures. In this paper, we have implemented two no reference IIQA measures. One is saliency based and another is degree of noticeability. And these two measures are compared with the proposed subjective analysis, and a comparison is drawn from the both. So basically, the perceptual image quality in accordance with the subjective evaluations, it is a very complex and unsolved problem due to the absence of the pristine reference images. Hence, greater challenge is posed by this no reference, that is NR, image quality assessment IQA measures. So let us have a look at the quantitative assessment of the method by using no reference IIQA measures. Here the quality metric proposed in literature 13 is given as average saliency values or average squared visual salience, which stands for ASVS, which is equal to summation of S dash P square upon mod of ohm, where this S dash P is the saliency value of the pixels in the unknown region, which is calculated through the spectral residue model. The saliency, which basically linguistically, if you talk about saliency is nothing but any feature which stands out from its background. So the saliency values of the pixels in the unknown region can be calculated by using the spectral residue model, which is given as R of f is equal to L of f minus A of f, where A of f denotes the general shape of the log spectra, which is given as prior information. R of f denotes the statistical similarities that is particular to the image input image and is defined as the spectral residue of an image. The L of f is the long spectrum and is computed from the downsampled image. The saliency map is calculated by taking inverse Fourier transform of the spectral residue. The second metric which has been implemented in this paper for comparison with the subjective analysis is the degree of noticeability, whose purpose is to identify inpainting sections that are not visible. It indicates a change in attention outside of the inpainted region. So a low degree of noticeability value indicates a better inpainting result. So equation number 3 is used to calculate the degree of noticeability, where S dash y is the saliency value of pixels in the unknown region after the inpainting, and S of y is the saliency value of pixels in the selected region before inpainting. So these are the steps for quantitative assessment method by using the no reference IIQA measures. So first an image is selected, the inpainted image is selected. Then a mask is selected, a saliency map is created over that mask. Then the saliency of the indented pixels, indented region is calculated. From that, a sum of squared salience, that is ASVS, is calculated. I have implemented paper 19 here. I have shown the result saliency map of paper 19 here. The degree of noticeability should be as low as possible. So as compared to the second paper here, degree of noticeability is bit better. Hence you can see from this column number 3 as compared to column 2, the impending result is more visually plausible, because here more these trees and all, which was not necessary, it was it is protruding into the water, whereas this looks to be very natural. So as you can see here, the results are compared, but we can infer from this table that though the observer score is high for this Wang's image as compared to the degree of noticeability and ASVS, so there is a contradiction here, that though it is visually plausible to the human perception, but to the average salience score or through the degree of noticeability, we can infer that it is not visually plausible. So these two are contradicting each other. Hence, though there have been many methods invented for image quality assessment of the imprinted image, but these methods, they cannot compete with the human perception. Hence still the subjective analysis is the stronger one among both. So here the comparative analysis of ASVS and degree of noticeability is given. So we can conclude that the impending problem has to be approached differently for every image, and it cannot be generalized to all the images. When the impending is applied to remove the damage in an image, then most of the time the reference image is available. But if the same impending is applied to the image where an object is removed, then the reference image is not available. Here, the full reference or reduced reference IIQA measures cannot be used. In this paper, the IIQA measures of the impending is discussed in brief. A method of the subjective analysis or subjective assessment, which is also called as the qualitative assessment of the impending, is suggested. A survey is conducted on the observers of varied educational backgrounds who belong to different age groups as well. And the quality of impended image is determined through the average score of the observers for that particular impended image. Now here, the future scope can be every image is treated differently here, and the results cannot be generalized. So we could use support vector machines, classification techniques for creating a predictive network which could predict the qualitative human opinion and suggest a generalized approach to this impending assessment, quality assessment. These are the references. Thank you.
Yes, Asutkar sir, it's time for question answer. Yes, Asutkar sir.
Yes.
Yes.
Am I audible?
Yes, sir.
So what tools you are using for image grabbing and analysis?
So here, imprinting was performed on the images using the MATLAB software. I developed an algorithm in MATLAB to perform the imprinting of the images. But the result which was to be judged, that result is judged under two categories, either quantitative or qualitative. So here I have proposed a qualitative method, which is human perception, to judge the quality of the result of imprinting. And I have shown in comparison where quantitative analysis shows that though the structures or the imprinting is poor, still quantitative value is more than the qualitative one. But as per human perception, which we tend to find the continuities in the region as well as texture, our perception is that we find the continuity. If a line is broken, we visualize that the line is continuous.
Hello.
So that human perception is more powerful than the quantitative one. Sir, am I audible?
Okay. One thing more, one thing more which you mentioned in your presentation, that there is a comparative. So which database you are supposed to be used for entire analysis,
So I
and what is the authenticity of that?
created my own database, sir.
You created your own.
Yes, sir. And I have also used few images from Bishnupur heritage images, which I haven't shown in here for the structural continuities. But basically, most of the 99% of the database is created by me.
Okay. So now, Khobragade sir. Hello.
Yes, yes.
Ha.
Shweta,
Yes, sir.
do you have any paper regarding this imprinting by using some types of transforms?
No, sir, I haven't implemented some type of transforms.
But do you have any references?
No, sir, I haven't included these references here.
No, in this list, any paper on transforms, impending using any type of transforms, whatever references you have shown.
Right. Sir, I am not aware of it because I am currently studying the impending using GAN networks. So I'm not aware of the transforms yet.
No, actually what I mean to say is whether you have included the depth information, depth. I am seeing from the pixel point of view, but if you take some types of transforms, say how transform and other transforms, so depth information you will get there.
Right, sir. So only problem is this result. If I use high resolution images, then it takes a very long time for the algorithm to complete the inpainting. So I had scaled down the images and so all the images included are of scaled images.
Okay.
Thank you, sir.
Okay. Madam, can I ask one question?
Sure, sir.
Madam, see, if we are using a standard algorithm such as Kreminsky algorithm for this impending of images, okay?
Right, sir.
So we have a mask region where the pixel has to be reconstructed, okay?
Right.
So Kreminsky has used a priority-based pixel selection, means which pixels to impend first depends upon the priority. Have you worked on that particular thing? How the particular priority is assigned to the pixels on what basis? See, we select there are n number of pixels in the mask region, and we select one at a time.
Right, sir.
So what criteria you had used there?
Sir, I have already published few papers on the impending algorithm, which I have created and compared with the Kreminis's algorithm. So in this paper, I have only included the quality assessment of these images, but the priority of the pixels, it is determined by a product, a data term and a vector and a data term. So which boosts the confidence of that patch. So that has been given in my other papers, where I have a different approach where priority is decided by using the intuitionistic fuzzy sets.
Okay, you had used the same method that is a part of Kreminsky algorithm.
So here I have shown standard 2 algorithms comparison and quality assessment by proposing my standards.
No, I am asking in a general way.
Right.
So you had used that confidence and data term.
Yeah, confidence and data terms, sir, I have calculated using my approach, and I have compared it with the Kreminis's approach. That is another paper actually. So I haven't included it here.
Have you able to reduce the time complexity while impending?
So I could switch to another platform because I did this programming in MATLAB. I could use Python to decrease that time. Even C programming is proven to be more efficient because the overheads are less. So I haven't ventured there. But now with the advent of neural nets and all, this more plausible answer can be obtained by using convolutional neural nets. So I'm currently working on that GAN networks.
Any pre-processing stages before impending?
I have scaled down the images. That is only the pre-processing applied, nothing else. because if the images of higher resolution, like where I had used Bishnupur heritage images, they were super resolution images. So it took a very long time to complete a small portion. So I had to scale it down.
Okay, means some part of the features are lost during scaling.
Yes, sir. Yes, sir.
Okay, thank you, madam.
Thank you, sir.
Okay, thank you, Shweta. Now it's time for paper ID 254. Yes. ID 254 presenter Nita is present there?
Yes, madam. Yes.
Okay.
Hello, everyone. I am Nita Limbarti from Yashwantrao Chavan College of Engineering. My paper title is Change Detection of Vegetation by Satellite Image Analysis. These are the contents of my presentation, that is introduction, state of art, methodology, simulation, and results, and conclusion. In introduction, in change detection process, we can identify the difference in the object or phenomena for different type of periods. Now, in figure 1, we can observe the different images for the different time period and the change in the phenomena of their inputs. Okay. Now, in the state of the art, here I explain one survey paper, that is change detection techniques using optical remote sensing. So, in this survey paper, authors reported number of techniques and algorithms for analysis of change in vegetation through different measuring parameters like accuracy, time, and cost, etc. This is the flow of my algorithm. That is, first we are considering the input satellite image, then pre-processing, then image segmentation, classification, and finally accuracy assessment of the input images. Now in methodology, I have considered the input image and apply pre-processing to enhance the quality of input image. So we have applied here histogram equalization and brightness inversion method. Then to identify the objects through segmentation method. After segmentation, we have applied here the classification methods, that is supervised classification and unsupervised classification. Here you can observe the input image, and in a segmentation algorithm, we are highlighting the objects, different objects through the segmentation method. Now, in a supervised classification algorithm, we have considered here the maximum likelihood classification method. Firstly, in supervised classification method, firstly we have defined the signature files. Here you can observe the signature file. Here for in signature file for vegetation, we have defined some colors, that is gray color and pink color, you can observe here. Then for identification, we have already use maximum likelihood classification method. So you can observe here that this is the input image, and after applying this supervised classification method, we are getting this output, and the vegetation area is defined by this pink and gray color, which we have already defined in a signature file. Okay. In result analysis for supervised classification method, table 1 presents the vegetation area calculation for supervised classification method. For the period of 6 months, analysis is carried out as the winter comes. From November months, vegetation area is increased. You can observe here 18 point, then 23, 24, 26. So the vegetation area is increased here, while in the month of March, the vegetation area is decreased due to the change in the season. And in the table 2, we can observe here the difference between the vegetation area of the 2 months. So this is the analysis for the supervised classification method. In unsupervised classification method, we have used ISO clustering method. This ISO data clustering is nothing but the iterative self-organization data analysis technique. In this method, user have to define number of cluster for classification. In figure 7, here the input image is defined, and figure 8 is the output for the unsupervised classification method. Here also, as I have already explained, you have to observe the vegetation area with the color of pink and green in unsupervised classification method also. Now for unsupervised classification method, table 3 present the vegetation area calculation. Now here for the month of November, December, January and February, the change in vegetation is very less as compared to in unsupervised classification method. And here you can also observe the difference between the 2 months calculation. So the variation is quite different as compared to the supervised classification method. Now we are getting here in supervised classification method, the accuracy is more as compared to the unsupervised classification method. Because in supervised classification method, user have to define the signature file for particular area. So we are getting the results are good. But in supervised classification, we are just defining the number of cluster, means how many objects are there in that particular image. We can't define their signature files like that. That according to number of cluster, software consider the colors for particular area, and according to that we are getting the output in unsupervised classification method. So due to this, there may be some misclassification will be occur in unsupervised classification method. Here we have considered the different images for the month from the month of October to March. So, and these are the outputs for supervised and unsupervised classifications. These are the outputs up to the month of March. So from this analysis, from visual analysis also, we can conclude the area for supervised classification method is calculated properly as compared to the unsupervised classification method. And finally, we can conclude that the supervised classification method gives better result as compared to the unsupervised classification method. And this analysis is useful for town planning in agriculture fields and many more in application it is used. These are the references. Thank you.
Okay, it's time for question answer. So Asutkar sir, hello. Yes, Asutkar sir.
Yes, madam.
Okay.
I'm Nita. Nita, madam.
Yes, yes, sir.
So, which satellite images you are using? What is the source of images?
Sir, this project is done in collaboration with MRSAC Nagpur, and we have collected the images from MRSAC.
Okay. So, do you have that data?
Yeah, whatever images they are provided.
Complete data they allow you to access their database. Do you know that kind of data?
Yeah, for education purpose, they provide some data, not in a big amount, but there may be 10 to 15 images they provide.
That needs some permission, no?
Yeah. We have a collaboration with MRSAC in our department.
So where are you working?
I'm working in Yashwantrao Chavan College of Engineering.
Okay. So you do have access to MSAT data.
Which Which
Because
side?
they are using different tools. They are using different tools for the same analysis. Which tools you are using?
Sir, I'm using their IDAS software. They provide the license, student license version.
You know which tools MSAT is using?
No, they not provide MSAT. We use only the IDAS, whatever they provide, and according to we do the analysis.
One more question. When you mentioned in your presentation that you are doing this analysis on the these are real-time images, or how it will work on, what are the challenges you will face when you are using it for the real-time images?
So, sir, actually, we have to, they not giving the real time. They provide the images in MRSAC, and we have to go there and do this analysis.
If you wish to modify the same work for the real-time image, what you will do?
Yeah, we can say that it is a real time because we whenever they access the images, they provide directly there. Even online, they show the images. We can choose the area of that from that image, particular area, and we can do the analysis there. That could also possible.
Okay. Okay, it's over from my side, ma'am.
Okay.
Yes, Khobragade sir.
Okay, ma'am, no problem. You can continue with next.
Okay. So next ID, so I'm going for the 329 ID. So ID 309 and 329. Hello, are you present there?
Yes, madam. Pratik Hazare, 309.
Sir, we are not able to play your video. It is giving some error exceeding size. Do you have your PPT along with you?
In video form, madam?
No, normal PPT you can directly present.
PowerPoint presentation.
Madam, in this laptop, I don't think.
So ID 329, Chetan Mahatme. Are you there, Mahatme sir?
Sir, you can.
Madam, sorry to interrupt. How many presentations still remains?
Only 2.
Only 2. So including this 329 or excluding?
Yes, how many?
Excluding.
4. Sir, total 4.
Okay.
So ID 329, after the ID 329, ID 154. ID 154, are you there?
Okay, Pratik sir, you just email your PPT and present.
Yes, madam. Can I start the video?
Yes, but I don't know your audio will be shareable. Okay, well, try from your side.
Are you able to see this, madam?
No.
नाही त्यांचं आहेच नाही दिसून.
त्याच्यात व्हिडिओ गेला बरं.
Is presenting today for this international conference on emerging trends in engineering and medical sciences. On behalf of my co-authors, is presenting today for this international conference on emerging trends in engineering and medical sciences.
Sir, your video is not visible and your audio is also very low. There is some issue with your video. We are not able to share even that video.
Are you able to see this video, madam?
No, there is some issue with your video.
To directly share your PowerPoint, sir.
So if you could share your PowerPoint, that will be the better option.
Yes.
Display नहीं होता है.
आहे मी इथे नाही मला माहित माझ्या स्क्रीनच होणार आहे म्हणून. स्क्रीन शेअर करू का? मेल कशाला करू दे? मेल पाठवला आहे प्रेझेंटेशन. फुल स्क्रीन होऊन जाईल. शेअर इकडे हे आहे. मोठं करू? ते म्यूट काढलं का मी? म्यूट काढलं का? म्यूट काढलंय ना. स्टार्ट व्हिडिओ. हॅलो मॅडम. हॅलो मॅडम.
Yes, sir.
Madam, are you able to see this?
Yes, sir.
Okay. Should I present now?
Yes, sir.
Okay. Good morning, sir, and good morning, madam, and good morning, other colleagues. I am Pratik Hazare, and I am presenting today. This topic is stationary wavelet transform based heterogeneous features to detect spliced images. And my other co-authors are Narendra Giretkar, Prashant Patil, Poonam Agarkar, Avinash Lambert, and Sujata Bhele. So detecting authentic and false images have been widely focused research area today. An image can be tampered and edited. It can fool intelligent eyes to detect even a minor change, thus making it authentic. The free and abundant availability of easy to use image editing software had made difficult in detecting this particular false images. The forging mechanism is too simpler and it is hard for the naked eye to detect. Today, unauthorized user intercept images and modify those using splicing techniques, which cannot be perceived by human eyes. So therefore, it necessitates to design a robust expert system to validate image authenticity. The advantage that the splicing introduces some amount of distortion that can be used to detect false tampered images. So splicing, when a portion of an image is copied and pasted onto the same image to cover or replicate a region, it comes under the copy move technique. It includes undifferentiated placement of part of some other images into the host images. So this can be done using the contents of the same image, or this can be done by just cut and copy and move from other host images from an abundant data set. Okay. So what is our condition? It uses the upper level bands of stationary wavelet transform using Haar mother wavelet decomposed to first level. The frequency domain features are then extracted in multi-scale from subbands of SWT. So here we had neglected the approximation coefficient, and we had used the other three coefficients in vertical, diagonal, and horizontal directions. Then the second is Markov model based statistical features are extracted from bands other than low frequency band to obtain the transition probability matrices, which are used then to extract the heraldic texture features resulting from gray level co-occurrence matrix. So this is the other side. So we had used both types of features, that is statistical features and textural features. Now the significance of using this stationary wavelet transform is that we don't want to lose any information. So as other conventional wavelet, when you decomposed an image into its levels, then some particular information is lost. So that's why we are using here stationary wavelet transform. We had experimentally found that Haar mother wavelet has given better accuracy in detecting the spliced images. Then this is the block of the system. So the input image that's first converted into YCBCR components. Then we had individually select the CBCR component. We don't use the Y component. And there is another approach that we can use the average of CB and CR, or we can combine CB and CR. So all the particular three components have been used here, but the last component we use the mean of CB and CR. Then we apply the first one level stationary wavelet decomposition, and we selected the three bands, that is LH, HL, and HH. Then we calculated the difference matrices. The equations is given on the left hand side. These are nothing but the gradients along horizontal, vertical, diagonal, and the reverse diagonal directions. Okay. Now the block diagram shows two parts. One corresponds to the extraction of statistical features, and the other corresponds to the textural features. So then finally we combine both the features, giving almost 300 and say about 300 features, and the other subbands, that is this is for one subband, that is LH. The other two subbands are similarly worked out, and then we combine all those features that will give 102 samples for one feature, one image. And then we had used the classifier, that is SVM, and we had classified whether the image is authentic or spliced images. So in the first part, we had used the transition probability matrices from the difference matrices, and on the other hand, we had used gray level co-occurrence matrix, and we used the mean and standard deviation for these. Okay, a threshold has been used to subject the particular differences matrices in the range of -3 to 3. The value of threshold has a different effects on the results. Okay, so this is the algorithm. The original forced or real image is transformed into YCBR color space. Then we had selected the component either CB, CR, or and the mean of CB and CR. Then it is subjected to one level to stationary wavelet transform, and we had applied the whole thing on each component. Then 4 difference matrices are constructed for selected 3 subbands to produce that is difference matrices in vertical, horizontal, diagonal, and reverse diagonal, that is minor diagonal. Then the elements of the difference matrices are filtered using the threshold that is given by if it's the value is greater than t, then it is t. It is less than t. It is less than minus t. Then we substitute t, and if it lies between the t and minus t, then we keep the particular element as it is. Okay. Now that experimentally we found that t is equal to 2 is a better solution. We had used t is equal to 2, t is equal to 3, and t is equals to 4 also. Okay. So this is the threshold parameter significance. If it is very small, the unevenness due to forgery are not reflected in the probability transition matrix. And if it is large, the dimension of probability transition matrix will be large. At least complex computational complexity with no improvement in the result parameter. So experiment showed that 3 is equal to 3 is the optimum value considering all the 3 colors channel, that is CB, CR, and mean of CB and CR. So these are the probability transition matrices, that is P1H, P1V, P2H, P2V, P1D, and P1 underscore D, that is in minor diagonal. And the expression T 2 into T plus 1 and 2 into T plus 1 into 6 gives the feature set. So in all, there are 294 features, sample features for these particular probability transition matrices, along with 40 features are from GLCM. Okay. Then algorithm, GLCM matrices are constructed in 4 directions from 4 different matrices obtained in step 5. Textural features H1 to H5 are then extracted using the GLCM matrice, each different matrices along each direction. Then we had taken the mean and average. So in this way, we get 10 features for each of the component, that is each of the gradient component. The size of textural features thus obtained is 10 into 4 is 40. Now combining the statistical features and textural features from step 11, we get the resultant features for one band. So the size of a single band is 334 samples. So similarly, if we multiply for all the 3 bands, it will be 1002. The final feature set consists of combination of all features set from all sub 3 bands components. Now data set, we had used the Cassia v1.0 data set consisting 1721 images of dimension 384 by 256 and 256 by 384 dots with JPEG format. But we had rescaled them to 125 by 125. Okay. The number of authentic images are 800 and number of the spliced images are 921. And the labels we had used is for 1 for spliced image and 0 for this particular authentic image, that is 1, and spliced image, that is 0. It uses a binary classification with support vector machine, and the cross validation using random selection of 25% test samples were utilized, and the performance of the proposed system was evaluated in terms of performance parameters. So we had selected 25% random sample from the given samples. This is the result analysis. You see for T is equal to 2, the CR component is, the accuracy of CR component is 99.30. And the CB component is 06, and for T is equal to 4, we get a maximum accuracy of 99.9, and the other parameters are shown in the graph, that is accuracy, sensitivity, specificity, precision, recall, and F1 score. Here is the comparative approach with other methods. Mohammed et al. 2014, Agrawal and Chan 2015, Alamadi et al. That is 2016, Shen et al. 2017, and Vidyadharan 2017. And the last bars corresponds to our proposed method. So we got an accuracy of 99.30 maximum for T is equals to 3. sorry, for t is equals to 2, sensitivity of 99.1 and specificity of 99.5. So this is the comparison between other state-of-art methods. Then comparison based on dimension of features. Agrawal and Chand has used 2048 features, while the minimum features were used by Shen et al. That is 96. We are between both of them, that is 1002. So not too less and not too high. So with 1002, we are having an accuracy above 99%. This is the comparison based on type and size of features, accuracy and attacks. So you see, in most of the literature, it is found that either they had used statistical or structural features. This comparison is to show that our proposed method uses both types of features, that is statistical and structural. Okay, and the accuracy, the maximum accuracy was found by Shen et al. Using TF GLCM, that is 98.54. Got an accuracy of 99.30, and this particular database is affected by a replay attack. Now conclusions, only using only the textural feature or statistical feature, the accuracy rate lies between 94 to 98 and 94 to 96.43% respectively, whereas using both textural and statistical features, the performance is improved to 99%. The proposed technique incorporating hybrid features yielded 99% accuracy, which outperform others. Thus, it can be concluded that considering both feature recognizes the distortion introduced by splicing and improves the accuracy. Despite a higher dimension feature vector, separate feature selection approach is not required in our case to boost the performance. The future scope aims to apply the system on other standard dataset and evaluate the performance. The system can be made robust by employing deep learning approaches for feature extraction process and other use of other classifiers. Detect the splice regions in the forged image. This is our forthcoming, this will be our future work, that we have to detect the splice region in the images. Okay, and these are the references. Any questions?
Yes, Asutkar sir. Asutkar sir. Hello. Hello.
Track 6 मध्ये ना सर?
Oh, track 6.
Pratik, I want to ask one question.
Yes, sir.
Regarding heterogeneous, actually, what do you understand in your title? Heterogeneous is there.
Sir, it means mixture of two kinds of features, that is textural and statistical features. That's why we had given the name heterogeneous.
Okay, static.
Hello, sir.
Hello, Khobragade sir. Khobragade sir. Khobragade sir.
Network issue.
Asutkar sir. Asutkar sir. Okay, Pratik sir. Thank you.
Okay, madam. Thank you. I think they had network problem.
Yes.
Okay. Thank you, madam.
Okay.
Network.
sir. Yes, sir.
Problem झाला जाऊ दे आता. Okay.
विचारा सर, विचारा. काही प्रॉब्लेम नाही आहे सर मी.
हाँ मैडम बोलिए.
हाँ सर, क्वेश्चन पूछना था. Yes sir.
Madam, some audio problem at your end or my end, I don't know.
Okay.
Am I audible?
Yes, you are audible, sir. You are audible, sir. Again, he left. Me, he is there.
Yes, I am there.
Okay, sir. Pratik sir, thank you.
Okay, madam. Thank you, madam.
Okay, sir. So next paper ID 88. Be ready.
Okay. You want to present the video or you will be playing the video?
We are presenting the video here, okay?
Okay. This diagnosis. I am Nakul Pranav along with my co-authors to present this paper in this conference. Actually, Alzheimer's disease is a progressive disease which actually destroys the memory and other important mental functions. So this disease was quite popular in American countries, and actually the people above the age of 65 usually get affected. But nowadays young people are also getting affected. Though there is no cure for this disease presently. Only thing is that we can detect it at an early stage. So this image illustrates the brain of the Alzheimer affected patients and the normal healthy brain. So the main objective is to actually predict whether Alzheimer's disease is present or not. If Alzheimer's disease is present, then it will classify as mild, very mild or moderate depending upon the cases. So the data set used is the images of MRI scan were taken from Kaggle dataset. We splitted the dataset into 80% data for training and 20% of the data for testing. The data actually consists of 4 classes of images in training as well as testing dataset, which is mild demented, moderate demented, non-demented and very mild demented. So this is the summary of this paper. Deep transfer learning models. 4 models we have implemented. The first thing is the ResNet 50, second thing is the DenseNet 169, third thing is the EfficientNet B0, and fourth thing is the VGG 16. So the main drawback we faced in deep learning is that we usually face in deep learning is that actually if we increase the number of layers at a certain stage, this exploding or vanishing gradient may occur, due to which the weight becomes 0. This is one case, or else the weight becomes very large value. So the training and test error rate also in turn increases. So there are some solutions for this. The solution is that we can use skip connections, or else we can add the previous output of the layers. This second architecture is being used in the transfer learning models. Actually, compared to deep learning, transfer learning gives a good result since it already uses a pre-trained network, and also it requires less training time. First thing is the ResNet 50. In ResNet, actually the element-wise addition is actually being used, and this is the diagram of the ResNet 50 block diagram. And the steps involved in this is that data set collection, pre-processing, importing the base model, building the ResNet 50 model, training the model and testing the model. So in this image, the performance metrics were plotted as a graph. Total number of 20 epochs were run, and parameters such as accuracy, loss, area under curve, precision and F1 score were plotted. This is the model summary. Total number of layers being used is 6 layers, and the accuracy we got around 80%, and the precision, recall, AUC and F1 score were also displayed in the slide. Moving on to the DenseNet 169. Compared to ResNet, the only difference in DenseNet is that actually we obtain additional inputs from all the preceding layers, and actually this also passes its own feature maps to all the subsequent layers. This is the only difference between ResNet and DenseNet. Compared to ResNet 50, DenseNet 169 gave some better results, and the process involved in this is that the dataset collection, pre-processing, importing the base model, building the DenseNet 169 model, training the model and testing the model. So the performance metrics graphs were plotted. Here also we took a total number of 20 epochs. The accuracy we obtained was around highest as 85%. In this, the total number of layers is used is 3 layers apart from the base model. So the third model is the efficient net model. It is a lightweight model which was designed by Google for image classification. In efficient net, scaling actually is done in depth, width and resolution. In depth, we actually increase the number of layers. In width, we actually increase the number of channels or feature maps. In resolution, we increase the number of pixels. The step followed is also the same: dataset collection, pre-processing, building the efficient net B0 model, training the model and testing the model. Here actually, if you see that we use the compound scaling as a scaling ratio. To scale actually depth, width and resolution, a baseline model is needed. So the baseline model we used is efficient net B0. Here it is available, total number of architecture is B0 to B7. On scaling, B0 will get B1. The same applies for all the layers also. And efficient net B0 architecture is also displayed here. And a total number of 20 epochs were also run in this case, and here accuracy and loss is plotted. The total accuracy we got is around 96.92%. This performs well when compared to the previous models, I think. Also other performance metrics were plotted in the table. And VGG16, the final thing, it consists of a deep network which consists of around 16 layers, and VGG16 actually especially is well suited for high resolution images. And these layers usually consist of the combinations of convolutional layers, max pooling layers and fully connected layers, which will be stacked accordingly. The below image is the VGG16 model architecture diagram, and here also here we took around 50 epochs were totally run, and training and validation loss and training and validation accuracy were plotted. VGG16 performed better when compared to all the previous 3 models. The high accuracy obtained was the highest of around 97.4%. Also other performance metrics such as precision, recall, AUC and F1 score were obtained was also high when compared to the previous models. This model performs well for this data set. And moving to the future scope, what we can do next is that we can collect the real-time MRI images and we can prepare data set by ourselves. And the next thing is that we should implement this model in the real-time hospitals, and we should check how it works and all. And this is the demo video of this one. In the first test case, we gave a non-demented image, and we are getting around 67.56% of the image to be non-demented. It is correctly predicting. And in the second image, we gave a moderate demented image, but it is showing as 54.5% to be very mild demented. It is wrongly predicting. In the third test case, we gave a mild demented image, and it is correctly showing it as mild demented with around 40%. And in the last test case, we gave a very mild demented image, and it is getting around 35.2% to be very mild demented. It is correctly predicting. Okay, and then moving on to the next slide, this is references, and finally, thank you.
Okay. My question.
Sutkar sir.
Yeah.
So any questions?
Yeah, I do have one question. Do you what the analysis you made in your paper? This analysis, do you have any consultant with any neurologist or the person who is concerned to the medical field, or you do individually?
So actually, you are speaking about the dataset, right, sir? Dataset was a predefined dataset which was collected from Kaggle, sir. Actually, in the future plans only, actually dataset was already taken from Kaggle. We didn't prepare any dataset. In the future, if we work now, we thought of collecting the dataset from hospitals and preparing the dataset by ourselves in the future scope.
No, but I think in most of the image, particularly the image processing related to the medical field, we need to consult at least one person who is from medical field. Okay,
yes, yes.
Technical part is okay. Technical part is okay, but as far as your analysis is concerned, we are not technically sound enough to make any conclusion on any images that you acquired or you analyze. That's what my concern.
Okay. So your concern is in future we'll implementing this in the real time and all for collection of data sets and all. It's better to consult with the doctors and prepare accordingly the data sets you're saying, right?
Yeah.
Okay. We'll
Because
work
we are not competent. I think we are not confident because we are not technically sound for medical.
Yes. It's correct.
So that's what we are expected for all the medical images which you presented. Some doubt in my mind, that some concern is in my mind that I share with you. Apart from this, something which you mentioned in your presentation is already in existence.
In existence, but we improved just the performance metrics we improved.
Up to what percentage you improved?
The highest was 97.2 in VG16.
The 97 is too high. 97 is too high.
Actually, the existing in this data set, actually in our data set, this is the highest. Actually, we increase the number of epochs and we performed accordingly so that this we got around 97.2 in VGG16. Other than that, efficient had been not 96.92%.
One more question. Here you acquire the images in a VGA.
I didn't get it.
What's the total size of your images for analysis?
Actually, it consists of 6,400 images totally. In that,
not number. What is the image size?
176 cross 208.
Okay. What is the data size? What is size of image?
Size of each image you're asking?
Because no, actually what I say is, now for the analysis, we are using the HD, 4 HD images or 4K HD images.
Okay.
For research purpose, particularly in case of medical imaging.
Okay.
And the size you used in your paper is too small. Why?
Okay.
Why you are not refer here the HD images?
Actually, the data set we used is need to update it because the only thing we got is from Kaggle. It's from the next plans, future plans, and the next work and all. We thought of collecting it in real time and preparing the data set.
That's old data.
This was taken from Kaggle, so Kaggle data set. This was also latest around. It was around
That's
last
what
year.
I said. That's what I said. You just go and refer any medical practitioner, particularly neurologist, because they are using the image acquisition device for all these images. They do have very high-end images.
Yes.
Yeah, and if you are using it in paper, so refer them. Okay, thank you. It's all from my side.
Thank you, sir.
Hobragade, sir, any questions?
Thank you. No question.
Thank you, sir. Next paper ID 329. Are you there, sir?
Yes, sir.
Sir, can you present from your side?
Just a minute. Share screen option is not working.
Just a second, sir. So now you can try.
Share. Just a minute.
Excuse me, sir. Sir, it's not audible. So, sir, please check your volume.
Sir, you are not audible.
Sir, you are not audible.
Unmute करो.
Sir, please unmute yourself.
Sir, it is visible?
Yes, sir, it's visible.
Okay, okay. Just a minute.
So, good morning, good evening to all.
Sir, is it audible now?
Myself.
Yes, sir, it's audible.
I'm presenting on behalf of my colleagues and my co-authors, Mr. Jayant Giri, Dr. Jayant Giri, Dr. Rajkumar Chadge, and Dr. Punit Fujele. We three, Chetan Mahatme, Jayant Giri, and Rajkumar Chadge are from YCC College, Mechanical Department, YCC College, Nagpur. And Dr. Punit Fujele is from DMMS, Wardha, Savangi Megi, Wardha. Our paper ID is 329, and the paper title is Brain Tumor Segmentation and Model Optimization for 3D Printing. Okay. So let me first give you an introduction about our research. So the first point is medical image acquisition. So generally, when a person met with some physiological disorder or accident, doctor generally prescribe that person or that patient basically to go under medical scans. And these medical scans can be an MRI scan or a CT scan. So MRI stands for magnetic resonance imaging, and generally it is used for soft tissues. And a computerized tomography, that is CT scan, generally used for bony structures like the orthopedic structures, bones, skulls, rib cages, etc. So these two techniques are widely used in medical field for acquisition of medical images. Okay, and these images are basically stored in the electronic forms when they are scanned through these medical scanners. So these images are in the form of let's say a DICOM file. A DICOM is basically an image which is used for medical image acquisition. And these DICOM files are basically taken by the scanner in number of planes like axial, sagittal, and coronal planes. And these planes basically have multiple DICOM images. And when these images are stacked and combined together, generally provide one single file which is called as a nifty file. So this nifty file, or it can also be an NRD file. So these files are basically stacks of DICOM files which are generally gathered by the scanner. So the idea behind medical image segmentation is that can we analyze those medical images and can we segment out the region of interest from it? Like a doctor wants to have a look at the image and wants to know if it is a bony structure and it's a scan for a fracture. So he wants to know if the fracture is there or not. Okay, so the segmentation process can help the doctor to point out the fracture, or it can also be used for neurological the skull breakage, skull fractures. It can also be used for vertebral columns disorientations. It can also be used for neurological disorders, brain tumors, liver segmentations, heart segmentations. So all these things can be done with the help of this medical image scanning and their segmentation. So for segmentation purpose, generally use image processing algorithms, and these algorithms are generally used on these images and a segmentation has been carried out. So the process till now was the manual segmentation process. Like we take the images, we import those images in the softwares. Some softwares are proprietary softwares, paid softwares, and some proprietary softwares are open source softwares like 3D Slicer. So we generally take those images, we load those images, DICOM files in the software, and we manually segment the portion of interest or region of interest. And it is a cumbersome process. It takes lots of time and lots of expertise to separate out the part, and the process is basically a time-consuming process. Okay. So next is, in this paper, we have used a methodology. So as you can see in the workflow, we have a MRI scan data of patient selected for case study. Then secondly, we have done some manual segmentation of ROI in 3D Slicer software. And after that, we created a 3D volume of that ROI. That 3D volume is then exported in the form of STL model, which is generally used for 3D printing. So a 3D volume is basically converted into an STL model. This STL model has inbuilt errors because of the manual segmentation process. And those errors are structural errors on the surface, inside the body of the object volume. So those errors are basically, we want to reduce those errors. So we have imported that model into a Autodesk NetFab software. And after that, what we have done is we have estimated the error and we have optimized that STL model with the help of Autodesk NetFab software. And we have created some scripts inside in Autodesk NetFab software to remove the surface errors and STL errors. And after that, we have compared the optimized and non-optimized STL models so that we can gain we can say evaluation of how much errors are optimized and are reduced with the help of this technique. Okay. Next is, in this case study, as you can see, the specifications of dataset that we have used is we have selected anatomy of a brain, and the image which was used for segmentation is Nifty image, and the file name was BRATS 221. This image dataset was taken from medical image segmentation decathlon from it is an open community, and it is a competition which was held for testing the algorithms of different teams on the basis of their scores. So this dataset was readily available, freely available, and it is under open source license. So we can use that for our study. So we have used that dataset here, that's 221. And NI is the extension for Nifty file. And modality was MP-MRI, multiparametric MRI, and protocol was FLAIR, and the target was edema or enhancing and non-enhancing tumor. So the study which was done on this data set was to study for the non-enhancing and enhancing tumors. So we have used this data set from a patient. Next is what we have done. We have segmented this MRI data. As you can see in this screen, the images A, B, and C are basically the tumor segmented part. So the green region that you can see here is the segmented portion. And for segmentation, we have used a thresholding effect. And in this thresholding effect, we have set some intensity range, that is 883.79 to 213.2.65. So this intensity range, when set for these MRI scans, so the region which was a tumorous region is now highlighted in the green color. And this segmentation was done simultaneously in 3 planes. First one was axial, second was coronal, and third was sagittal plane. So all the 3 planes were used for separating out the image. Next this is the output of this segmentation process. As you can see, the 3 planes of brain MRI scan, as you can see in the image A, it is showing the output of a segmentation process, and image B is enlarged image of that tumor. This tumor is the separated tumor from the brain, and this is the volume or surface model which has been created with the help of this segmentation process. Okay, it is a 3D model. Then this 3D model is imported in Autodesk NetFab. It is a 3D printing software generally used for analysis of 3D parts and 3D models. So what we have done, we have imported that volume or surface model from 3D Slicer into a NetFab. We have meshed that part, and during meshing or STL creation, we can see here there are multiple errors in these geometries, like the STL errors are generally the triangles are not perfectly aligned, you can see, or the triangles are having multiple faces. Also, there can be open border edges on the surface, the triangles are not closed. Sometimes the mesh is open and the triangles are not there, surface has holes. And because of that, as you can see, the part which has been generated has multiple surface errors. And such type of models, when used for 3D printing, these STL models are then used in 3D printers for 3D printing. So when such type of models are used in 3D printers, so 3D printers do not know what to do with these holes, the open border edges, and the inverted orientation of triangles. So in that way, the 3D printed model becomes, we can say, a faulty model. Okay, erroneous model. So these models, when imported in NetFab, we have done some repair scripts. We have used some repair scripts generated in Lua language, and these Lua language scripts are then utilized in Autodesk NetFab. And these surface holes, surface inverted triangles, and the border edges, all those errors has been recovered or repaired here. So as you can see, this is the model before repair, which is having some surface errors, surface deformities, and this is the model after repair. Okay, so as you can see, this is the non-optimized model, this is optimized model. Optimized models has the mesh is basically a closed mesh, open border edges are none, surface holes are also none, and inverted orientation of triangles is also none. That means this model is perfectly suitable for slicing, and after slicing, it can be perfectly used for 3D printing. Okay, so this is basically the output of our research work. So what we have done here is we have selected one patient, MRI scan, then segmentation process. After segmentation, we have separated out the volume. Then we have converted into an STL model. That STL model has errors, and those errors were used or errors were then repaired with the help of the scripts that you have generated in the Autodesk NetFab software. These are the outputs. So conclusion of this study is like these images, the medical images, generally are 2D images, and they do not provide any depth information on the anatomy of the body. Like if you are using MRI scans of a brain, it do not provide any depth image, or we can say depth effect on these images. So doctor doesn't know how much depth the tumor has. If there is a tumor, the tumor has grown. So it generally depends on the expertise of a doctor. But if we can convert these medical images into a 3D model, so that 3D model will be more visually appealing to the doctors. They can get multiple informations from that 3D model, and those 3D models will be, we can say, true to shape, and they will be more efficient for the doctors to predict the effect of the tumor. So if these 3D models are printed, so what will that do? That those 3D printed models will provide you in hand effect of how much the tumor shape and size is, what is the structure of the tumor, in what area it is enhancing, in what area it is reducing, and other things, and how it is affecting the surrounding environment inside the brain. So all these things can be analyzed by the doctor, and it can be further used for the surgical procedures. Like the doctors can do virtual surgeries and plan their surgeries in hand beforehand, before going for the actual surgery on the patient. The patient can also be made aware of his condition, like how much the tumor size is, where it is located, and what are the complications, what are the we can say the effects of this tumor on the body parts. All these things can be taught to the patient effectively by using these 3D models. So because of these faulty models, those things were not possible, or what we can say, those things were not that much effective. So if these models, like optimized models, are printed, so they will be true to shape models, and they will be more actual representation of these 3D models of the tumors and other things. Now, in the future scope, these 3D models can be converted, or you can say detected from the medical images automatically, or segmented automatically. And the techniques which can be used are machine learning techniques. Generally, deep learning techniques are generally used for segmentation. So if we can use these machine learning techniques, like the Python tools like PyTorch, PyVista, and if we can segment the parts and directly create error-free STL model by integrating 3D slicer with Python environment. So these things will be much beneficial to the doctors, experts, and the medical community. So this was the wholesome idea in our project, in our research work, and I hope this is basically useful to the medical community in future. Thank you.
Thank you so much, sir, for your paper presentation. Sutka sir, any questions?
Same question, what I asked to the previous researcher. See, in most of the cases, when you are dealing with the image processing, you do have any consultant person is from medical field?
Sir, our co-author is Dr. Puneet Filjale, and
Puneet Filjale from
DMMS.
Yeah,
okay. Yes, and he provided some inputs on these neurological images and the tumors that we have created. So if they are true shape or not, and what are the difficulties while processing those tumors, those will be addressed by Puneet sir.
Okay, so you are working at Varda?
No, sir, I'm in a mechanical department of ICCE.
See, you mentioned in your presentation, do you use machine learning or deep learning in your research work?
No, sir, we have done manual segmentation.
So that's what my same question is. When you are having AI or machine learning and deep learning,
yes, sir,
this is already used by so many researchers. So
yes,
you are already, why you are not using that?
Sir, currently deep learning is used for automatic segmentation for MRI images. And the output that we are getting is again an image. It is not a 3D model. So those images are again we have to use for creating a 3D part. And those 3D parts are converted into STL. And when one main problem with STL is, as I mentioned in my presentation, that when we slice that STL model directly coming from the segmentation process, it has multiple surface errors. The surface is broken. And during slicing, the printer, the extruder of the printer do not know where to move. So those parts are not, we can say, accurate to ship, and they are not generated directly. So if we can, although there are segmentation algorithms are available, and by deep learning, we can convert MRI images into a segmented part, but we need a structure through which those segmented portions can be converted into a 3D, and that 3D portion will be of STL form having surface accurate to shape. So that was the I have mentioned.
Okay. So it's hello.
Yes, sir.
It's all from my part. Now it's to you. It's over from my part.
Okay.
According to 3D printing, Chetan is presenting. Are you
Yes,
Chetan?
sir. Yes, sir. Yes, sir.
Oh, actually, do you have any references regarding this 3D printing part of say tumor? Any other means, or this is the first application you have developed?
Yes, sir.
Is it the first application you have developed, 3D printing or 3D model that you have developed from MRI images?
Yes,
Is
sir.
it the first one, or do you have any references? Previous references?
Sir, previously the models were created from Slicer.
Okay.
People generally use MRI and CT scans for separating out bones and tumors and other things, but they have not worked on the reduction of STL errors. So the main area, the research work was what? The output of this slicer was STL, and that STL has errors. So the application that was done here was, how can we reduce the STL error so that it will be 3D printing ready? So that was
okay, but you won't get then some means how do you differentiate that whatever you have created is okay or not? How you will verify?
Sir, that comparison model is shown in the presentation, sir. Currently, what has the STL model has meshes, and meshes has triangles, because STL stands for standard tessellation language or triangulation language. What we do here is, when we get a segmentation 3D volume.
No. What I want to ask is whatever you have created, the
Yes, sir.
final product.
Yes.
So how do you say that this final product is perfect? What is the accuracy? What is the precision that whatever you have made is up to the mark? Do you
Okay.
have any standard?
No, standard is not there, sir.
To check whether whatever you get is it means correct?
True
It
to
is
shape.
correct.
Okay, so that
So
tumor
do you have any quantitative analysis like values? Do you have any values?
Values on the
Parameter
tumor shape and size.
Yeah.
Okay, so sir, tumor shape and size is basically depending on the threshold intensities in the image. So
that you can mark only,
yeah.
But
Yeah.
Actually, or in terms of quantitative analysis, I mean to say in terms of values, whether you are getting low values, high values, whether they are approximate or coming to the true values, standard values.
Oh, that validation is not there, sir. It is basically
that will come from the previous references. What I mean to say is
okay.
है ना, तो previous references and now your error reduction part.
Yes.
So that has to be compared somewhere.
Okay, sir. Sure, I will do that.
Okay.
Yeah.
Okay. From my side.
Thank you, sir.
Okay, thank you, sir.
Next paper presentation, ID 154.
Is there Priyanka?
Priyanka ma'am.
Priyanka ma'am is there? Yes. Priyanka ma'am is there? Okay, so we can. Yes, sir, our presentation is now over. Asutkar sir, share किया आपने?
नहीं.
Share करो. PPT रहेगी ना?
चला लीव करायचं मग मॅडम?
No, sir.
Yes, sir. Asutkar, sir. F5 Karan. Okay. So now presentation is over, and this is the moment. This is the memento from our side as a token of gratitude. Thank you very much, sir. Asutkar, sir, Vice Principal PC. And next, our own session chair, internal session chair, Dr. S. Khobragade, sir, Atish Khobragade, sir, and this is the token of gratitude from our side. Thank you very much, sir.
Thank you. Thank you, ma'am.
Okay.
Thank you, sir.
And participants?
And participants, please kindly wait for 5 minutes. Validatory function will begin soon. Thank you.
And join with the same.
And join with the same link.